some time ago. He's a lecturer and a teaching coordinator in undergraduate and postgraduate programs at the University of Minho, Coimbra, Santiago Compostela, and São Paulo, Brazil. He holds the professional title of Consulting Engineer, awarded by the Portuguese Association of Engineers, or Engineers Portugal, or Ordem dos Engenheiros, as you may want to say, and was also president of Ania, the European Federation of National Engineering Associations, and finally president of the World Federation of Engineering Organization, this among other things. So we look forward to hear to these two gentlemen, to whom I said that they have 7 minutes each to speak. Please.
Your Excellencies, distinguished engineers, engineering leaders, presidents of engineering institutions, national and international engineering institutions. It is indeed my pleasure to welcome you to this session on energy transition and sustainability. Actually, this is a conference that is supposed to take a whole day or even 2 days because of the importance of the conference. But the fact that we have squeezed everything to 2 days, that is why we are just giving it like half a day. But we shall try as much as possible to make sure that the topics are covered adequately. Energy production and consumption is an issue of great concern to every nation on earth, and there is a positive relationship between energy and economic growth. Income and energy consumption are tightly correlated on every continent and every country across and every period for which data exists. Nowhere in the world you can have a wealthy country that consumes little energy, and you can have a poor country that consumes a lot of energy. So the richer a country is, the more it consumes energy, and vice versa. The development phase of nations regarding energy production and consumption determines their priorities in that sector. While some are battling to meet electricity access and percentage availability, some are more concerned on how clean and sustainable the energy production process is. For those of us who come from sub-Saharan Africa, there are so many countries that do not have 100% access to electricity. And in some situations, even those who have access to the electricity, the availability of the electricity also is under a big question mark. So to them, that is a huge challenge to meet the access rate and also the availability. To put it clearer, what percentage of the energy generation is fuel-based, that is coal, oil, and natural gas, and what percentage is from renewable? The current global scenario shows that fossil fuel-based generation still accounts for about 80% of the energy mix globally. This scenario, if left to continue, will cause global temperature rise due to carbon emissions, which will be detrimental to our future. The aim of this conference is therefore to discuss and propose solutions, reversing the energy mix, or how we can transit from a sustainable transit through a sustainable manner from a predominantly fossil fuel-based energy mix. And that is why we coined the theme of this conference to energy transition and sustainability. As we march to the future, we envisage an increase in population, about 10.4 billion people by the year 2100, which comes along with more energy and food consumption. Of course, the more you have people, the more you have energy consumption. But of course, the energy consumption is not necessarily because of the increased number of people, but because of the increased lifestyle of people. The lifestyle of people changes over time. Available data show that the global per capita energy consumption has increased by 62% since 1965. In numeric terms, it has risen from 17,984 kilowatt hour in 1990 to 21,039 kilowatt hour in 2022, which means that there is an increase of about 3,000 kilowatt hour per capita on each human being globally. And that explains why there is surge in energy demand globally. The production and use of energy are therefore more than ever before at the center of each country's strategic considerations, not only due to the need for decarbonization policies in energy systems, given the emission of greenhouse gases and their impacts on climate change, but also due to the issue of energy autonomy and economic independence of every country. Agreement adopted at the United Nations Climate Change Conference, COP21, is to limit the increase in the global average temperature to a maximum of 2 degrees Celsius above pre-industrial level, with a commitment to restrict this temperature increase to 1.5 degrees Celsius. It recognizes that the global energy crisis, beyond its impact on climate change, poses a significant challenge to efforts to achieve the energy security. However, data from global carbon projects show that the 2022 emission level is 41 gigatons per year. If we want to limit temperature rise to 1.5 degrees, we only have 6 years to achieve this with reasonable likelihood of 50%. For a target rise limit of 2 degrees, we have approximately 28 years to achieve the same 50% likelihood. In other words, we must achieve net zero by 2050. In practical terms, the 1.5 degree target is extremely unlikely to be met given our limited emissions budgets and lagging efforts. And for the 2 degree target, it is still not on track as far as what we have on ground today is concerned. With these realities facing us directly, we must therefore marshal all resources to put 2 degrees back on track, as higher temperatures pose tremendous biodiversity threats. An average global temperature rise of 3 degrees Celsius can result in 41% of mammals losing their habitat. This is a very serious scenario which must be avoided. It will be recalled that COP28 held in Dubai calls for the world to transition away from fossil fuels in energy systems in a just, orderly, and equitable manner, accelerating action in the critical decade so as to achieve net zero by 2050. This signifies that a rapid shift from the fossil fuels and redeveloping whole system to operate on low carbon electricity. Therefore, all available options of low carbon or clean carbon energy generation, that is hydro, solar, wind, including nuclear fusion. We have to really put this nuclear fusion technology to use if we must achieve this by 2050. Must be put into consideration in the energy equation if we are to achieve like 77% renewable energy target by 2050. Your Excellencies, distinguished engineers, mine is an opening address. The technical papers will be presented by eminent scholars, and details of and the communique of the paper presentation will be received by all of us, and it is our duty as leaders to share it with our governments, national governments, regional governments, and international governments for further action. I thank you very much.
Dear fellow engineers and friends, good afternoon, ladies and gentlemen. As the world's largest association of international engineering organizations, WFEO is committed to the implementation of the United Nations Sustainable Development Goals. It actively collaborates with national and international professional bodies to tackle both global and local challenges, leveraging pioneering engineering solutions and policy frameworks for the betterment of humanity. Our world is experiencing unprecedented changes, making a pivotal moment in history. We are facing numerous significant global crises. In such a context, the production and use of energy are more than ever at the center of the country's strategic considerations, not only due to the need for decarbonization policies in energy systems, given the emissions of greenhouse gases and their impacts on climate change, but also due to issues of energy autonomy and economic independence that COVID-19, armed conflicts, and epic geopolitical divisions have dramatically highlighted. The theme energy transition and sustainability, besides its political, social, economic, and environmental implications, constitutes a significant matter requiring active involvement from the field of engineering. The decommissioning of conventional fossil energy plants and the massive development of variable renewable energies can pose issues of continuity and quality in electricity supply. Backup power plants, cost-effective and efficient energy storage technologies, demand flexibility development, and electrical grid development will be necessary to overcome the variability of renewable energies. The issue of access to energy in general and in electricity in particular remains a significant challenge in many regions of the world, requiring different responses for supplying large development megacities and remote off-grid locations. Engineering for sustainable development is especially critical in developing countries to mitigate the effect of climate change, reduce poverty, and design relevant infrastructures and development models. The implementation of scientific research and technical development projects in the field of energy systems engineering underlies industrial transformation, innovation, and global economic structure. Especially in the context of increased tensions in the relations between humans and nature, it is crucial for engineers and policymakers to adopt a balanced approach between economic progress, social justice, and environmental preservation, which is fundamental for a country's energy security. Esteemed delegates, welcome to this pivotal conference on energy transition. Together, let us embark on a journey of collaboration and innovation, forging a path towards a more sustainable and prosperous future. I wish you all a very successful conference. Thank you very much.
Let us keep the pace, but I was asked by the organization to deliver a small commercial. That is, there are buses at 7:30 to take you from here to the restaurant this evening. 7:30 p.m., just outside, for those of you that go to the restaurant. Is it okay? Yeah, yes. Lorries or buses or trucks? Well. Buses. From here, from outside. Yes, yeah. No, from the main entrance, the main old entrance, which is in the other building. Well, it's in this building. It's in this building, yeah. Okay? Well, I'm going to give the floor now to Professor Gong, that's the World Federation of Engineering Organization past president from China. Is director of Chinese Institute of New Generation Artificial Intelligence Development Strategies, which is a very relevant thing, and chairman of the Academic Committee of Nankai University. Professor Gong has obtained the Chinese National Award for Technical Inventions and for the Teaching Excellency, as well as many other awards from Chinese and international organizations. The floor is yours till 3 o'clock.
Thank you, Chairman, for your nice words. And good afternoon, dear colleagues. It is my pleasure to be here to celebrate the World Engineering Day with you together. I believe the World Engineering Day has a dual meaning. On the one side is to show up the engineering achievements for the sustainable development and call attentions, supports from the public, from the government. Recently, the Chinese government has done something very good for engineering development. They have decided to establish a dedicated national award for engineers. So, since this year, it's the annual national award. So, but on the other hand, the World Engineering Day is to call our engineer society to increase our awareness on our role in the sustainable development. So my topic is given by the organizer, the role of engineers in the energy transition. So I try to present what I understand on this topic. I start from this graph. That is from the report of the IPCC Group 1. And here you show the dark one. The dark black one is observed variable of the Earth's surface temperature, the average. And this dark brown one is simulated. We use the simulation. In the simulation, we use all factors, including human activities and natural activities like earthquake and so on and so forth. And here you see the confidential, 90% confidential region of the simulation. Here you see all observed temperature variable are within the confidential regime. So that means this simulation is relevant, is meaningful. Then we remove all human activities, the factors from human activities. We get this one. The blue one. So the variable of the Earth's surface temperature is around 0. So that means this gap is made by human activities, especially by energy-relevant human activities. 73% of this increase is made from energy-relevant human activities. So of course, all engineering activities are also human activities. They're badly dealing with energy. And engineering activities as a significant part of the human activity increasing the global surface temperature. So that's our role in the climate change. So, on the other hand, engineers' role is also crucial in energy transition because engineers are crucial in energy generation, transmission, distribution, and application. Because engineering practices is dealing with energy and related greenhouse gas emission. While engineering works rely on energy, the energy transition in turn relies on engineering and engineers. So here I cite the words from the engineering report, UNESCO engineering report released 2 years ago. And here we give some good examples showing engineers are already working on energy transition successfully. But that is not enough. We need to do more, and we can do more for the transition away from the fuels in energy system. So engineers are to increase our awareness of the goal of energy transition. That's goal 7, ensure access to affordable, reliable, sustainable, and modern energy for all. There are 3 targets under this goal. First is by 2030, ensure universal access to affordable, reliable, and modern energy services. The second target is by 2030, increase substantially the share of renewable energy in the global energy mix. Third is by 2030, double the global rate of improvement in energy efficiency. So all of these are our works to make this a reality. So we have to meet the challenge of ensuring the energy transition benefit all people, especially those 800 million people without modern energy services. So this number is for the year 2015. The newest number is about 700 million. But the pace of the progress is slowing down during the COVID in the past years. So, and engineers are to integrate digital technologies, including artificial intelligence, in the further electrification to empower the energy transition. Here I show you the different part of the electrification need our engineering works, and which could be empowered by digital technology. So engineers should have the capability to make full use of the emerging digital technology properly to increase the efficiency, stability, safety, and reliability in energy services and applications. Engineers are to further leveraging zero and low emission technologies to deepen the transition. Here you show the first page of the document of the COP28 last year held in Dubai. And this document called the first global stocktake. In this document, it called further recognize the need for deep, rapid, and sustained reductions in greenhouse gas emission in line with the 1.5 pathways, and calls on parties to contribute to the following global efforts. I just cite 2 of them. First is accelerating zero and low emission technologies, including inter alia, renewables, nuclear, abatement, and removal technologies such as carbon capture and utilization and storage, particularly in hard to abate sectors and low carbon hydrogen production, and accelerating the reduction of emissions from road transport on a range of pathways, including through development of infrastructure and rapid development of zero and low emission vehicles. So that means engineers should understand the carbon footprint of his or her engineering practice and master related skills to achieve zero and low carbon emission. Furthermore, engineers are to ensure a safe and stable energy supply during the transition. I remember last year in Prague, Mustafa, in his presentation, he has said African could not transit in dark. We have to supply the energy at first. And the challenge comes from the volatility of renewable energy supply, the changeable supply of renewables, and the complexity of coordinating online supply, consumption, and the maintenance systems of the renewables. And we have to ensure the transition adapting to the regional circumstances and context. Regional contexts differ in natural resources, disasters, and risks. COP28 stressed that the strategy related to just transition and economic diversification should be implemented, taking into account different national circumstances and context. So that's also our job, to have engineering solutions in the national, the local context. And so on and so forth. Because the limitation of time, I could not mention more. The engineer's role, in summary, is to make the energy transition away from the fossil fuel a reality. On the COP20 Earth, nearly 200 countries for the first time recognized the need to transition away from the fossil fuels. A rapid and far-reaching transition across all sectors and systems are necessary to achieve deep and sustained emission reductions and secure a livable and sustainable future for all. That my cite from the document of Dubai, COP28. And on the closing session of that important conference, United Nations Secretary General, who is also the member of our Portuguese Order of Engineer, emphasized that the era of fossil fuels must end with justice and equity. He said, the global stocktake must offer a clear plan for a tripling of renewables, a doubling of energy efficiency, and a single-minded focus on tackling the root causes of the climate crisis, fossil fuel production and consumption. I think to answer the question posed at the very beginning, what is the role of engineers in the energy transition? Our role is to implement the plan, the tripling the renewables, doubling the energy efficiency, and a single-minded focus on tackling the root cause of those crises, that is fossil fuel, and to solve the problem by engineering practices. So in summary, energy transition is imperative and of great urgent to sustain humankind and the planet. All engineers are responsible to this comprehensive energy transition in every engineering position. To take on the engineer's role in energy transition, engineers should have a strong sense of social responsibility to fully understand their role in energy transition and strive to improve their professional capabilities to carry out the transition. WFEO, the World Federation of Engineering Organizations, unites all engineers across the world, men and women, to engage into the energy transition with responsible and innovative engineering practices. So here I end my presentation by this word: transition away from fossil fuels, starting from ourselves, starting now. Thank you so much.
Thank you very much, Professor, for very motivating words. Our next speaker is going to speak about Portugal and the energy transition, some vital strategic questions. A man who has been working a lot on these issues, Professor Clemente Pedro Nunes from IST, Portugal. Professor Clemente Pedro Nunes is a full professor at the Instituto Superior Técnico, coordinator of the International Energy Agency's National Process Integration Group, vice chair of the International Energy Agency Technology Cooperation Program within IETS, vice president of the Scientific Council of ENAC, the National Strategy for Adaptation to Climate Changes from the Ministry of Environment, and councillor member of the Ordem dos Engenheiros and full member of the Academy of Engineering. The floor is yours for the next 20 minutes.
So thank you very much for the presentation, Sebastião. We are both chemical engineers. I will speak today more about electrical systems because it's a very important process. So thank you very much to the Ordem dos Engenheiros, which is a house that I belong also for almost 53 years. I joined at the same time as António Guterres. We both graduated at the same month in Técnico, so we see that we have some knowledge on that. He's, as you know, an electrical engineer. I will present here a case study, and the case study is the Portuguese energy transition in the last 25 years. Portugal has, as you know, and was very well said by our Chinese colleague, the engineers have a very important mission in terms of optimizing the system and making the connection between technology, science and technology, economics, and then what relates to practical items. As we all know in the business world, the devil sometimes is on the details, so we have to be very careful. It is very important for us to view this aspect, so I very much thank for this opportunity. This electrical system in Portugal is one of the main challenges. That's why I chose and I proposed to José Professor José Vieira to speak about this item, because it's very challenging and we have a very, I would say, hard experience, and we have to understand and to learn from practice. So it is very important that in the case of Portugal, we are very much integrated in electrical systems with Spain, then with France, not so much, but we are also. And of course, we are very dependent on the decisions that are taken in Spain, in France, and above all in the European Commission, that, as you know, have a very strong positions in this case. So this is the global framework. In the Portuguese electrical system, basically we started to have a major expanded system after World War II, and it was based at the beginning of an hydroelectric plan that at the time was a big revolution by Professor Ferreira Dias, who was a member of economic ministers at the time. And in the other main item we should take into account was that the last global energy plan that was made in Portugal was in 1983, and it basically decided two things: not to go ahead with the nuclear power plant as a firm and a reliable source of electricity,
and instead go for coal and natural gas at the time, 1983, both imported. This was the baseline where we had when we started the next development, which was the revolution of the introduction of the intermittent power sources. That renewables are not all intermittent. You have hydroelectricity that you can store, and you have also biomass, and you have others. But wind and solar, which are the main, let's say, fashionable and now being developed, they are in fact intermittent. Not only variable, but intermittent as such. The problem was that when that was put forward in 2004, 2005, it was made without the total and global economical assessments of which any planning has to do. You have to study the alternatives, to fully analyze it in technological and economical ways, and then to decide for the best available option. So this is the main question. And then there is a technical question that most engineers know. When I'm speaking from non-engineers, this is a very hard topic. But as you know, electricity as such, which is an electronic flux, it cannot be stored. And this is totally different from the other resources we have in terms of final energy products. We can store gasoline, we can store biomass, we can store natural gas, but we can store coal, but we cannot store electricity. So this is an extremely important factor, together with the factor that the new renewables, or some of the new renewables, they are intermittent. So you have here a complex cocktail, almost an explosive cocktail. So we can now see how is that is applied in our case. So as electricity has to be used at the moment that is produced, this is a very extreme complex situation. So in Portugal, and then you have the economy, you have the technology, and you have the contracts. So in order to make this investment profitable, to make, under quote, what was done was the so-called feed-in tariffs, which is an expression that basically means that whenever the guys that have a feed, they are guaranteed to be paid when they produce, irrespective of the consumption. And the second point is that they are able, as such, to expel the competition. If you have a feed, if someone is coming and you have already occupied the system, you don't have competition. So this was considered important in order to create the conditions to sustain the investment. But of course, you have a price to pay, as we are going to see. In 2011, the Portuguese government has granted 6,000 megawatts of intermittent power, of which the overwhelming majority was for wind, 5,400 basically, and 600 megawatts for solar at that time. But that is the problem. The consumption at empty hours, we call it in Portuguese horas de vazio, which is the hours of less consumptions, is only 3,900. So you here already have an arithmetic imbalance. You are allowed to be paid till 6,000, but in many hours you only have consumers of 3,900. And it is guaranteed on a contract, a legally based. Already in 2008, this made the first convulsion. There was a problem by which, at a certain time, the Portuguese authority, regulator of the energy system, which is called ERS, has proposed an increase at the time, I believe, about 18% or 17%. And of course, the government said that it's not possible because we depend on the elections, and the electors and the public doesn't like. So this made a Portuguese originality. We created a nation adept of the tariffs of the electrical system in 2008, and we still have it. And I will give you an information today that was just published today, which is even more serious, but I will speak that afterwards. So this debt became a very important one. It started 1,000 million euros, then it went up to 5,000 million, then went down, as we are going to see, and then last year, unfortunately, went up, and the last news are very worrisome. So this is the situation in terms of the price of the feed-in tariffs. In 2023, it was announced that this debt was going up again to 2,000 million euros. It has gone down to about 1,000 million, and in fact, minimum was not ever that. But now in 2024 was announced to 2,000 million again. And today, the papers published that is a forecast by EDP that in this year it will be increased by 1,000 million euros more. It's today in one of our main newspapers. So the target, although it has been announced 2 months ago, that this debt was not going to go up again. But now it's already going up 2 months later. And this means that the figure that is forecast is 3,000 million euros. So we are on the wrong track again. What is the problem that this makes? Because the FIT, they were granted basically for 15 years. So during 50 years, if you have a FIT, when you produce, you are going to be paid. But the problem is that if you have a new production, even of solar, and you want to sell in the market, if the market is already occupied, let's say a weekend, or even during the day that there are other productions, you cannot be able to sell in the network, which is called the national grid. So this is a very complicated situation, even for the new entrants. So you can have a situation when a new producer that is able to sell or is willing to sell, let's say at 10 euros per megawatt hour, it cannot sell because there is no room for it. And the consumer is paying maximum, in one case, I think it's 380 euros per megawatt hour. So you are forced to pay 380, not to pay 10. And the guy who has invested now on the new one with the 10 is going to be without any resources. He can't sell. So this is the situation where we have in our present situation. Well, this, in technological terms, we have to look at the 3 aspects: intermittent power, indirect storage of electricity, and the need to guarantee a power backup. You need power backup, of course. We need to have a stable supply, because if not, we have blackouts. So nobody wants to have blackouts. And even in economical terms, it's a disaster. Of course, in the modern society, we know that, of course, in some developing countries, there are limitations, but they are being overcome. So we have to produce, we have 2 alternatives. Either you effectively produce from the beginning at the moment you need, which is not compatible with intermittent sources, or you have to install a complex process by which you indirectly store electricity, because electricity can only be indirectly stored, and then supply when it's necessary. That is the 2 ways. So in case of Portugal, what are the 3 alternatives we have? First alternative is the one that is the best in our case, which is to use hydroelectric dams with water, in which, when you have excess production during a few hours or moments or minutes, then you can inject a reverse cycle, pumping water upriver. A few hours later, if the system requires again electricity, you turbine in the normal way, downriver. So this is the best way. It's expensive to some extent. You have to build 2 dams. You have to have 2 dams, one next to the other, in order to have the two-way system. So then you have to install all the system, and you play with the water, let's put it this way. The second way is to have what we chemical engineers call the reversible electrochemical reactors, which is commonly known as batteries, in which you make a chemical reaction which allow you to, afterwards, to produce, underquote, electrons. The third way is to have an intermediate chemical compound or molecule which you produce when you have excess electricity, and then later on, when you have a request for electricity, you use it again. In the case of Portugal, hydrogen, electrolytic hydrogen, is the main product that was proposed by our government to overcome this situation. What is the situation with hydrogen? Hydrogen can be used or considered in an electrical system to be a tool to promote the indirect storage of intermittent electricity. So you produce it in order to have available, you can store it. It's a difficult way, we shall see, but you can store it and then you use again. But you have to pay for all the system, which is, as you know, we have to see, it's very complicated. The problem is that, what are the problems, the real problems? We just mentioned that the energy transition has to be equitable and efficient. And we have a problem, is that hydrogen, the system is very inefficient in energy terms. Electrolysis of water is very inefficient, and the system to recover it is also very inefficient, or it is inefficient. One of the main problems to store hydrogen, which is the lightest molecule we have on Earth, we produce, because hydrogen molecule, as far as we know, is not in the nature, it has to be produced. So is that to condensate it in order to have a density, a reasonable energy density, you have to put in the liquid state. And that is very troublesome. Because as a temperature way, you have to go down to minus 253 degrees, minus. You are almost on the famous 0 Kelvin. And if you want to pressure it, you have to go up to 700 atmospheres, bars basically, which is a hell. Any mechanical engineer would say it's a hell of a lot of a pressure. So we have here to deal with these aspects, which for some politicians and some other people is not easily understood. So this is the way why engineers are absolutely essential to try to explain and to optimize a real system, not the make-believe system. So it is very important to let these developments to go in order to see how the prices really are going to decrease, as some pundits are forecasting. So, unfortunately, the resolution of the Council of Ministers of 2022 did not make any economical assessment. The other point I would like to raise to you is this question has promoted, as we are going to see, shut down the coal-based power plants. This meant that, as you can see, I don't know if this is working, but if you can see in the year of 2022, the last year of which we have reliable statistics by JEG, which is the Portuguese Director General of Energy, this has gone up to 1,000. Our liquid imports from Spain has gone up to 1,695 million euros. So you have this on the graph, which is much easier to see. And you can see the last, I think the laser is not working. Esta, a branca? It's not very, I see it's working. So the previous record was on 2008, in which we imported 634 million. Then we have 2 years of excess exports, let's say beneficial. But as you see, in 2022, it's an overall record. So we are here depending on Spain to avoid a blackout. Because in Portugal, with the intermittency, a backup in Portugal, you have to start up a natural-based power station for that purpose, and a few hours later, if there is wind and solar and sun, you have to shut it down again. Well, this is the situation we have. This is the figures. This is available to anyone to see. The maximum consumption we have in Portugal is around 2,000 megawatts at the peak hours, let's say, maximum consumption. So we have here a system which is, by the way, where are we? It's almost a nonsense because we have installed a total capacity in Portugal of around 20,000 megawatts, is here, production capacity, but we are importing because the system is in balance for operational terms. But the problem is not only that one, is that Spain, as it's a much bigger market and we are interconnected to them, the unbalance, or at least each company, each producing center is much smaller. If we go to the global imports of energy, every sources, you can see that the only one in which we are currently exporters is biomass and biofuels, is here, the last one, which is negative, which means that we are normally exporters. But all the rest, 2022, was a total disaster. We have imported, I have this on the graph, which is easier to see. The total imports it was 2022, almost to 12,000 million euros. That's almost 6% of our GDP in imports, liquid imports. This is the situation we have. How is that reached? Well, we have maximum is oil and derivatives, is the brown. Then we have natural gas, which is very expensive due to the price, and 2022 was a complicated year, as you know. And then you have the orange one, is electricity, which we have just seen. Of course, coal, that was in light blue. When we stopped our power station, we do not import anymore. But you can see that the price of coal, despite the fact that they have environment questions, in financial terms, is much more better. It's much more efficient because it's much cheaper. And it's produced by many other countries that are not controlled by OPEP. So this is the situation in which we have a very big imbalance in these terms. Just to have a number that is very important, we have the record last year was higher than the previous record that was in 2008, as you can see, and the difference was something like 3,612 million. And for the Portuguese, it's very worrisome to know that in 2008, the energy imports were one of the causes of the near bankruptcy of our country in 2011. So which is a little bit unwary. So I have to go a little bit further in order for time requirements. My colleague Sebastião Feyo very rightly points out to me. So what I can tell you is what I propose and what are the next steps to be carried out in Portugal. First of all, I think we should have to keep in operation the natural gas power station till 2045. It's currently apparently being discussed the new contract with the natural gas power station near Porto, which is Tapada do Outeiro, but the contract finishes this year, so we shall see. The interconnections between France and the Iberian Peninsula is very important because intermittent power without connections with France, it's very complicated because Portugal and Spain has more or less the same wind, in many cases, the same wind system. So we have to be connected with France. The last figures we have is about 3,500 interconnections. As we are going to see, this now is being increased to 5,300. The decision of the European Commission is to increase this to around 10,000, 9 to 10,000 megawatts, but it's not yet seen when that will happen. The other point is to increase biomass production in terms of electricity from biomass, in more 400 megawatts, which also is a way to help to clean the forests and to take away excess biomass from the land. The other point we have is to promote R&D projects to increase the capacity to store electricity, is the main question. A practical way in the Portuguese terms for engineers is to use the Zezer River, which is the one that is reasonably about 100 kilometers from Lisbon, and where is the water storage strategic reserve for the Greater Lisbon area, and where there are 3 dams, Cabril, Bocém, and Castelo de Bode, and to use a pumping station in order to be able to, let's say, indirectly store more electricity. But the most important thing we have, and this is the big challenge I would like to pose to you. We have plans, or the government has plans, to install something like 10,000 megawatts of offshore wind power. And about also more 10,000 megawatts of solar powers. The question is, who is going to pay for it? Is there going to be a feed-in tariff? If there is a feed-in tariff, who is going to pay? Where are the consumers? Where is the planning? Who is doing the calculations of what that will cost? It's very easy and very fashionable to say that we are going to make these investments. But where is the consumers? Are we going to pay again, or are we going to increase the depth of the electrical tariffs to what, 10,000 million euros? 20,000? Is there a new IMF intervention or European Central Bank intervention? These are the economics of the projects. This is a case study of a beautiful country that I invite you to visit that's named Portugal. Thank you very much.
Thank you, Clemente, for having taken only a few minutes more than you should. Now, the next speaker is Luís Mira Amaral, a former Portuguese Minister of Industry and Energy. He was Minister of Labour and Social Security between 85 and 87, and Ministry of Industry, I hope the numbers are right, and Energy between 87 and 92. He was chairman of Busy Angels and Bind Venture Capital SCR, and he studies a lot. And this is a very nice example. He has a degree in electrical engineering from Instituto Superior Técnico, a master in economics from the Nova Business School of Business and Economy, a postgraduate degree in management from Stanford, and he also attended the Strategic Management Banking Program at INSEAD, Asset Liability Management at Euromoney Training, Power Systems Reliability Evaluation at the University of Manchester, and the Program for Non-Executive Directors at the Portuguese Institute of Corporate Governance. Luís, the floor is yours, but still I want to mention that on these days a number of people mention his example as minister. No, joke, serious. As an example that should be followed by others in the next future.
I thank very much your invitation. I will speak about economic dimension of the energy transition. People are delighted to speak about energy transition, but unfortunately, many times they forget the economic dimension of the problem. In the real life, namely political life, we must take into account the economic reality. So I will try to explain you the economic dimension of this big, big problem that we manage now. Well, I have three short proposals. The energy transition all over the world after the European energy crisis that began before Ukrainian war, and sometimes the people forget it. People makes Ukrainian war responsible for the European energy crisis. It's a mistake, it's not true. And the third one, I will speak about the Portuguese energy system, complementing my colleague Clemente Pedro Nunes, and I will give some simple recommendations to the next Portuguese government. Common sense, simple recommendations about this energy transition. So, first of all, the world has seen several energy transitions from wood to coal. This happens with the first industrial revolution, from coal to oil with the second industrial revolution, and in the third industrial revolution, we remain with oil, but we began to introduce in the energy system natural gas. Now, in the context of decarbonization, we have the emergence of intermittent renewables energy, wind and solar, and we have the launch of the renewable gas, such as hydrogen, biomethane, as a non-fossil fuel alternatives to natural gas. So this is one of the main questions that we have now, because some want to suppress natural gas. They want to introduce hydrogen and biomethane to replace natural gas. Previous energy transitions have been led by the market in the decentralized approach between producers and consumers, with a gradual transition in which emerging forms of energy are assisted in their development by existing forms of energy. This is crucial for an energy transition. And if you read the economic story of the world, you understand that we had always this kind of energy transitions. We didn't suppress the incumbent energy source, and we tried to introduce new energy sources, but in a seamless transitions without the great problem that we are creating now. Nowadays, transition is being led by the visible hand of political power. This is the main economic mistake. Is the political power, is not the market that wants to make the energy transition. Namely, in the European Union and the United States, with Biden administration, obviously not with Trump administration, but with Biden administration, where the aim was to do away with incumbent energies overnight, replacing them, and this is not a realistic approach. This political approach, in my opinion, raises serious questions about economic and social sustainability of the transition. It could be said that the aim was not an energy transition, the aim was a genuine energy disruption. So they want to suppress the incumbent energies and to introduce a new world of new energies, forgetting completely the traditional energy source. This was a big, big mistake. And this doesn't work, because we see the world, we have always seamless transitions, not disruptions. And now we want to make a big disruption. We are also, obviously, assisting a resurrection of nuclear energy for the following reasons. Along with wind power, it's one of the lowest emitters of CO2 per unit of energy produced, which makes, obviously, the nuclear power attractive in the decarbonization framework. It has a high energy density. This thing, many people don't know it. High energy density of nuclear power. It means a lot of energy produced by space occupied, while wind and solar energy have a low energy density. This is crucial to take into account the transition and not forgetting nuclear power system, power plants. So it's not realistic in terms of space occupation to completely replace nuclear energy with wind and solar. This is crucial. People forget this point. It's a reliable and stable energy source, well adjusted to supply so-called baseload consumption. In nuclear power plants don't have the problems created by the intermittence of solar and wind power. So it's therefore common sense to recommend to countries that have nuclear power stations, keep them, because it's not realistic to replace nuclear power plant by wind and solar power. And I see every day a lot of engineers recommending more and more solar and wind power plants and forgetting nuclear power plants. It's a big mistake. And now, under the Iberian framework, Portugal has a serious threat because the socialist Spanish government want to phase out nuclear power plants. And if you have in Portugal, as my colleague, Clemente Pedro Nunes, explained you the support of the Spanish power system, and the support was created also with the contribution of nuclear power plants in Spain. So we don't have nuclear power plants in Portugal, but we have them under an Iberian framework because we are more and more integrated in an Iberian market. Portugal and Spain have now an Iberian market for electricity. So it's true that physically we don't have nuclear power plants in Portugal, but in a market point of view, we run an Iberian market. Portugal and Spain together, we run an Iberian market, and there we have nuclear power plants in our system. People forget it. So I am afraid that the socialist government want to phase out nuclear power plants, and they were crucial for our network stability, as my colleague Clemente Pedro Nunes explained you before. So don't forget nuclear power plants. We must take into account them because it's not realistic to replace nuclear power plants and to add only wind and solar powers to our power systems. This transition also aims to eliminate fossil fuels, but is highly intensive in mineral resources and rare metals to power wind and solar energy, batteries, fuel cells, electric motors for battery electric vehicles, and fuel cell electric vehicles. And in general, all the electrification that we want to do. So, also here, the people forget the supply side of the minerals that we need to make this energy transition. Problems on the supply side, such as the scarcity of these mineral resources and dependence on areas of the world that we don't control, such as China, or the constraint of available space for renewables, will create a serious supply shortage, slowing down the pace of the transitions. Generally, people forget this problem, the supply side of minerals. We want to shift from an energy model that is intensive in fossil fuels, but we want to create a new energy model that is intensive in minerals that we don't control. So this is another big problem, and we will have a slowing down of this energy transition because the supply side of minerals don't accommodate a so fast energy transition. This is crucial, but people are also forgetting this dimension. So about European energy crisis. Before Ukraine invasion, the world economy, namely Europe, began to deal with the first energy crisis under the decarbonization framework. As I explained you, Europe and the United States, under Biden administration, invest in fossil fuels, oil, coal, and natural gas. this underinvestment was made under the political commitment I explained before, but after COVID strong economic recovery, the world demands for fossil has increased a lot. And this creates a big shortage of fossil fuel supply. So it's easy to understand why the energy price increased dramatically. Either oil, gas, or coal. Portuguese press doesn't speak about it. They suppress this problem. Portuguese opinion believes that oil, natural gas, and namely coal, the demand for this energy source is not increasing all over the world. But nowadays, even today, the demand for fossil fuels is increasing all over the world. But Portuguese press doesn't speak about it. And the Portuguese people believe that we have a wonderful new world only with renewable energy, hydrogen, and things like this. This is not true. This is a big, big mistake. So obviously, I can say that Ukraine invasion exacerbates this energy crisis and has shown the dramatic dependence from Russia of European energy system, namely the huge German dependence from Russia on natural gas. Germany has made a big mistake. They gave up nuclear power stations, and they need more and more gas, more and more coal, and they are emitting more and more CO2. This is the wonderful world of German energy crisis that we have now. And as Germany is easy to understand, if Germany is the biggest European country, the problems that Germany creates, they are exported to our countries. So they create also a serious European problem on the energy side. So it was a big mistake to forget nuclear power plants. So Europe launched after the war an energy diversification strategy from Russia, namely natural gas, and tried to increase either the energy efficiency of the energy savings. Under this diversification, United States became the main liquefied natural gas exporter for Europe. So United States is now #1 exporting LNG for Europe. The second one is Qatar, but the United States until now was the first. But obviously this does replace completely the natural gas from Russia. So we are facing a transition in Europe that is not easy because United States and Qatar will supply more and more, perhaps Algeria and other countries, but it's not easy to suppress completely the supply from Russia in natural gas. Portugal, now about Portugal. Portugal needs to have again a true energy planning system. If you are speaking about economic sustainability, we need a true energy planning system with economic sustainability, not taking into account only CO2 reduction. I must emphasize that EU account only for 7% of world CO2 emissions, and Portugal account only for 0.1% of CO2 emissions. So it's crazy that Europe or Portugal alone will want to clean the world and suppress CO2. But when I see the conclusions in many energy conferences about energy transitions, I do believe they want that Europe and Portugal that want to be the leader of this transition in Europe, we will be able alone to clean the world and to suppress CO2. It's completely crazy, it doesn't make sense, but it happens every day in our country. I am not joking, this is true. Every day we see the Portuguese government, we see also many engineers and many colleagues that are delighted and they think they are able to solve CO2 world problem. We must deal with energy surplus of renewable sources, wind and solar. We must have redundant power from classical power plants when the wind doesn't blow and sun doesn't shine. My colleague Clemente Pedro Nunes spoke about it. We have here also a problem. And we need to build under the Iberian energy system new electrical natural gas connection between Spain and France to address the Iberian energy outer sea towards Europe. We are completely, in practical terms, we are isolated from European energy markets, either electricity or natural gas. So it's an Iberian and a European problem to address this kind of interconnections. In Portugal, in the context of the energy transition with sound economic sustainability, a new government after the elections should give priority. So I give some practical recommendations, common sense, decentralized photovoltaic solar energy for domestic industrial consumers who become prosumers. Prosumers means they are producers and consumers at the same time. So this is the decentralized approach that I suggest for solar power plants, because it's a mixed mistake what we are doing. A lot of mega projects that are an attack on biodiversity and land use planning. It doesn't make sense. It's completely crazy. The mega projects that we want to launch in Portugal when we have a better alternative. The better alternative is centralized photovoltaic solar energy, shifting the consumers to prosumers. This is the intelligent way to introduce, in my opinion, solar energy in Portugal. And block the approval of projects under self-consumption production units and renewable energy communities. Obviously, to introduce this approach, we need this kind of legislation. But it's very, very complicated, this legislation in Portugal, as it happened with many things, always a very heavy and bureaucratic approach to manage this. And I suggest that we will streamline and simplify the legislation. This is essential to run this decentralized approach. And also, we must stop the big tenders for offshore wind. My colleague explained also it. We want to launch a big investment for offshore winds, when the major players all over the world are giving up because the costs are so high that it's not possible that the consumers will pay the bill. So the major players all over the world are giving up this kind of projects, and the Portuguese government is delighted to introduce this approach in Portugal. Obviously, it doesn't make sense. Also, in my opinion, also we want to forget these big hydrogen projects with big experimentalism, mega projects, and we need to concentrate in small demonstration projects for industrial consumers, where electrification is difficult. The hydrogen technologies, the Portuguese government is delighted to invest in. They have no technological maturity. So forget big hydrogen projects. We must concentrate in demonstration projects, mainly where are consumers that need hydrogen. Some industries, some consumers need hydrogen. So we must concentrate there the hydrogen projects, forgetting mega projects that we see Portuguese government is delighted to invest in. Completely crazy. Obviously, also boost the production for biomethane. Biomethane needs non-fossil natural gas, so it makes sense. And after, boost lithium mining projects. Why? Because Portugal has the bigger European producer of lithium. we have biggest research, and we are not able to use lithium. Obviously, this is essential for our automotive cluster, because as you understand, we are shifting from thermical motor engines to electrical engines. In this transition, the electric vehicle has less components than the thermal vehicle, but has a component that is quite essential, the battery. And the battery is too heavy to transport. So it's crucial that it will be possible in Portugal to develop a value chain from batteries, from lithium to batteries to support our automotive cluster. This is a very serious economic problem because we have now in Portugal a huge automotive cluster. It's essential to support the cluster when we shift from the traditional vehicles to electrical vehicles. We need also stimulate energy efficiency among domestic industrial consumers, support municipal councils either in switching to LEDs in public lighting system. I don't understand why our municipalities didn't shift to LEDs in the public illumination. This is crucial, it's quite evident, and government forget it, is not supporting the municipalities. Also, I think it's a good idea to invest in battery electric buses to municipal vehicles. So it makes sense. And after, it's essential to remain with combined cycle gas plants, as my colleague Clemente Pedro Nunes explained before. Why? Because we have an electric system with a big component of renewable energy, and we need the power of the combined cycle gas plants when the wind doesn't blow and the sun doesn't shine. This is crucial, but this government forgot it. And we are now ending the operation of combined cycle gas plants, and the government forgot to accommodate the operation of this power plants. It's completely crazy, but it happens also in Portugal. And the last but not the least, under a long-term framework, we should return to real indicative economic planning in our power systems. We have the so-called National Energy and Climate Plan. I call it only National Energy and Climate Intention because it's not a plan, it's an intention from the government. It's not really a plan, and we need to shift from it to a real indicative economic planning in our power system to take into account the economic dimension of the investment in power plants in Portugal. So, short and common sense recommendation for the next government. I do hope that they will do a better job than the actual government. Thank you very much.
And we move now to the final talk of this part, Dr. Marlene Kanga. She's the former president from 17 to 19 of the World Federation of Engineer Organizations, this one, with 100 plus national continental members, representing 30 million plus engineers. She was the 2013 National President of Engineers Australia. But mainly, I would say mainly, to my point of view, she's an outstanding leader of STEM, science, technology, engineering, and mathematics, organizations in Australia and internationally, and an officer of the Order of Australia, a national honor for distinguished services to engineering as a global leader and role model to women. And she's a chemical engineer. So please, the floor is yours for the last talk.
Yes, I'm really pleased to join the other two chemical engineers here this afternoon. It gives me great pleasure to talk about energy. Obviously, we know nothing about the topic. I'm going to talk, hope my presentation comes up here. I'm going to talk about my day job. I'm president of World Federation of Engineering Organizations, the past president. That's my night job, and the work that I did on the hackathon that you saw this morning is all stuff I do at night. But my day job is I sit on various boards, and one of them is Endeavour Energy, and I'm going to talk about the energy transition there. I happen to be the only engineer on the board, and they've never had an engineer on the board before I arrived. I saw things straight away on day one, which they didn't see. There was a blind spot, and I've been trying to talk about things engineering with them since that time. So this is just my bio. For those who don't know the World Federation, this is our member map, and very proud to have Order of Engineers Portugal as a member. You can see our global representation there. And of course, our commitment to the Sustainable Development Goals and advancing them through engineering, which is what World Engineering Day for Sustainable Development is all about. I'm also going to reflect on the United Nations Global Sustainable Development Report that was released in 2019. And they showed that science and engineering was one of 4 levers to advance the Sustainable Development Goals. And there were 6 pathways, of which one was urban and peri-urban environments, or in other words, cities. So you see here the 4 levers and the 6 pathways, and at that intersection are cities. So I'm going to talk about the role of cities and the importance of advancing sustainable development for energy in a city, and the case study being Sydney, where I live. So here then is a map of the Endeavour Energy, which is we don't generate energy. The organization is a distributor, and so runs large transmission networks across mainly Western Sydney. So you see here on the map on the left, as it works, is all the states in Australia, and the orange area is the state of New South Wales, where Sydney is based. And you see on the right the map, which shows the area of operation of Endeavour Energy, and you can see Sydney in the grey there. And there are 2 other providers for Sydney, but Endeavour Energy is on the western side. This is an area of huge growth. This area also is where the new Western Sydney International Airport is being built and will start operating next year in 2025, and is slated to be one of the biggest airports in the world in another 20 years. And you can see the big region, which includes some satellite cities like Wollongong, which has a population less than 1 million at the moment, but set to grow. And this area is basically a greenfield site where there's going to be a population growth of around 3 million in the next 10 years. So very fast-growing area. So currently, Endeavour has 2.6 million engineers, 2.6 million customers, and a large proportion of those are pro-consumers with solar rooftop energy generation. There's been a huge explosion in response to high energy prices, the installation of solar PV, and many have batteries which they store and also for their own use, but also put back into the grid. So here again is Endeavour Energy by the numbers, 2.6 million customers, 207 substations, and you can see the 430,000 power poles. So in Sydney, we don't have a lot of underground, we have a lot of above ground power poles. One of the big risks is bushfires. So every summer we are prone to bushfires. So having vegetation management is very important for that. And we also have a lot of new industry coming in as well. And we have an absolute commitment to sustainable development. And here we have, I'm showing Scott Ryan, who's basically the asset manager and is also responsible for grid transmission and the commitment to sustainable development. I'm going to talk about the work that Endeavour Energy is doing and how the organization is navigating the social, political environment here and the risks that presents in addition to the technology challenges. And you can see down the bottom, this is a picture of the rural area where we are going to be building the transmission network. So this is green farms. And this is a pictorial representation of the transmission networks. And this gives you an insight into the kind of negative pressure the organization is facing from farmers and people in rural areas who do not want to see this come, and basically for the benefit of what they see as people in the cities. So here is Endeavour Energy's commitment to sustainable development, and they're very conscious about addressing climate change, managing biodiversity, especially as I mentioned, there's vegetation management, looking at reducing waste with the circular economy, and there's some targets there for waste management, and also looking at well-being and health of staff, inclusion, diversity and inclusion, and energy resilience. The organization has achieved a 5-star rating in the Global Real Estate Sustainability benchmark. And I've shown here an example. This is not what Endeavour rated itself, but it's an example of what's involved in this benchmark, and it starts with leadership for sustainability, policies, reporting, risk management, stakeholder engagement, managing air pollution, water, waste, biodiversity, etc. And there is a customer council which has representatives from various customer groups that we engage with on a regular basis to help inform these policies. And Endeavour Energy is ranked in the top 5% of global GRESB respondents, ranked 27th out of 649 infrastructure assets owners worldwide, and 2nd out of 8 participating electricity distribution companies. So quite an impressive list of credentials. And there's an absolute commitment to sustainable development among the staff as well. And here you can see the plan, and in fact, Endeavour is ahead of the plan. So basically looking at renewable energy sources, looking at reducing the customer the footprint, reducing waste, and commitment eventually to being climate positive, that is, with vegetation, planting more trees, reducing waste, and looking at renewable sources, reducing that carbon, not just to net zero, but to climate positive. So with this background of Endeavour's great aspirations to sustainability comes also the other side, which is the government and its policies. So the state government of New South Wales, where Endeavour operates, has a roadmap for energy. And Australia has large amounts of coal. In fact, we have enough coal to keep us going for the next 300 years. And we have enough gas, in fact, to keep us going for another 300 years, especially under Sydney, in the Sydney Basin. So it's a really tough decision to give up coal and gas because it's so easy to just dig it up out of the ground. But the government's committed to closing down coal-fired power stations. Many are more than 40 years old and beyond end of life anyway. So these power stations are closing down. And as we've heard from previous speakers, we're losing that grid stability as we move towards renewables. So we also need to look at where these solar and wind farms are going to go, and I'll talk about where that is. But also, Australia is a very large country, and so to get that electricity to the major capital cities, we need some 11,000 kilometers of transmission networks. It's a huge job. And it's not just a matter of the funding and finance to build it, but it's also the people, the skills. Because these transmission networks were built some 40 or 50 years ago, and we actually don't have the people with the skills to build these networks. They just aren't there. There aren't people with the experience to design them, and to build them, and so on, and to maintain them. So this is a huge skills gap that we're facing. And then, of course, as already the previous speakers have said, we need new storage and firming power to stabilize the grid and ensure reliability when the sun doesn't shine and the wind doesn't blow. So it's the same issue that we are facing in New South Wales. So the roadmap from the state of New South Wales attempts to bring together all the players. So at the top, you've got here the energy generators, the coal-fired power stations, the solar farms, the wind farms. Here you have the network operators, which includes, in fact, Endeavour Energy. And then you have the retail distribution businesses on the right. In New South Wales, we have policymakers which include what's called the consumer trustee, which is basically custodians of pricing to ensure that prices are kept as low as possible. We have Energy Co, which is responsible for designing the system, and the regulator, which is responsible for setting prices and therefore the returns that investors get when they invest in these new projects. These are appointed by the minister, the state minister for energy. And then we have, of course, a number of advisory bodies, including the Employment Purpose Committee, the Energy Security Target Monitor, the Renewable Energy Sector Board, and the Infrastructure Jobs Advocate. We have, at the moment, we have a left-wing Labour government, so you can see a lot of these, coming from their constituency as well. But you can see it's a very, very complex mix of stakeholders. And then finally here you've got retailers and consumers, and then you've got the financial trustees and how it's actually going to be funded. In addition to the roadmap, the state government has identified where the best locations are for wind and solar. So these green areas in the state of New South Wales show you the best locations for wind energy. And you'll see that actually they overlap, there's significant overlap with the best locations for solar energy. So, and this tends to be the higher areas. So it's not coastal, so the elevated areas, and so they're seen as being good corridors for solar energy. And the blue lines are existing transmission lines, so you can see the additional lines that are going to have to be built to enable these wind and solar farms to access the grid eventually and supply Sydney, which is the biggest source of customers for these investors. So again, the state government has developed a complex system of regulations and legislations to manage the establishment of what is called renewable energy zones. So these zones are areas which are considered suitable for wind and solar. There are 5 zones identified, and I will show you the map shortly. So here we've got, first of all, the system planning, which has already occurred. Then we've got the options and the 5 zones that have been identified. And then they called for bids for these zones, for one of them, which I'm going to talk about, the first one, which is called Central West Orana, or CWO. After the bids, they assess the bids, and they then say, okay, we'll authorize you. So Endeavour Energy was ranked first, but not officially endorsed as the winner. We were just ranked first. And this went on for more than 12 months. Finally, commitment deed was signed on the 18th of December 2023, where it was officialized that Endeavour Energy could build those transmission lines. Now we have to go further with further contracts. There's a list of some 26 contracts to be signed with the government and other parties. And we also, there's also a player there that will make a revenue determination, which is the prices, that will fix the prices before we can go ahead and start to transmit that electricity. Meanwhile, the solar and wind farms are also being approved and being developed. So you can see the complexity in the system and the delays that are being built in. It seems that things only happen just before Christmas. So at the moment, we have some dates that have been delayed from July 24 to September 24. We think it's going to be December 24, again, a Christmas sign. So here then are the 5 renewable energy zones, these gray areas. And you can, if you recall the map I showed before, it's the areas which are identified as having good solar and wind energy. And this is the Central West Orana renewable energy zone. This is the first one that's been approved. You can see here the town of Dubbo, which is quite a small town, and here is Sydney. And so this is the area where Endeavour Energy operates. And so this electricity has been brought on transmission lines from this zone to Sydney, including the new Western Sydney Airport. And here again is an expanded view of the Central West Orana zone. And I'd like to point out to you some small towns. You can see Gong and so on, which are very small. And I'll show you some photos of what those little towns look like. So this is a very rich agricultural area. It has lots of farming, lots of sheep and cows, grazing, and some fruit farms, etc. Again, here you can see the town of Orange, very small here. You can see the forested areas here, this thick green forest. And you can see some solar farms already identified on the map. So here's the signing on the 18th of December, and there's me sitting there. We have a partnership with 2 Spanish companies. So a new company, Ace Res, has been formed. Acciona and Grupo Cobra have joined with Endeavour Energy with 1/3 ownership each to form this Ace Res company, which ACE, taking the first letters of the 3 partners, to develop and operate this network for the next 35 years. So this was a very complicated process. We actually signed this with DocuSign. It was quite exciting because it went round the world. The people on the screen at the top are in Madrid, the Cobra and Acciona, and it went in sequence and took something like 20 minutes for each document. We had a number of documents to sign. So that's why we've got our laptops there, because it came on the laptop, we had to sign and went off, and you could see who had signed when. First time that they'd done it that way, and it saved people traveling. So I suppose it was a sustainable approach there. So here you see here again a greater detail of the network and the existing farms. The green areas are existing farms. I've circled the little town of Gong and Wellington. So Wellington is shown here. There's an existing substation in Wellington can see it's also rural. There's not a house in sight. And this is farmland that's owned by maybe a couple of farmers that own this land. So you can see the farmers are not very happy about it. It's a very rural area, and they don't want their way of life disrupted. So you see here that we formed the ACE-RES. Partnership will design, build, operate the transmission network, and it's the first renewable energy zone. It'll enable generators such as solar and wind farms and energy storage providers in the renewable energy zone to connect to the grid. It's a 6 megawatt system. We started off when we first got nominated as the winners with 3 megawatts. And when we signed, that's the time when the minister announced it's not 3, it's going to be 6. Nice, so just have to double the design. This will provide a reliable source of clean, affordable electricity, of course, and meet the state government's newly legislated net zero target. So like Portugal, very committed to net zero and so on. We have more than 300 engineers working on this project in Sydney at the moment, just in the early design stages. And of course, it's going to grow further. So here's a little bit about Acciona. We have Acciona building something across the road. They're a well-known constructing company. In Australia, they're actually building the airside facilities, that is the runway, which is already laid down, for the new Sydney International Airport. And they did the metro, Sydney Metro as well. So they're very well established. Cobra has this will be Cobra's first project. They're very well experienced in Europe. So again, because recognizing the lack of skills in Australia, we're coming to Europe and accessing the skills from Spain. This is the town of Gong. I had pointed that out to you previously. They don't even have a traffic light. Yeah. So you can see, again, the rural areas and the pressure there is. And here, again, is a visual of what a solar farm might look like in this very rural area. And so it gives you an idea that despite the benefits for health, education, and other services and increase in population, people just don't want it. This is another small town that's going to be affected. Again, you see no traffic lights. And so again, the disruption for schools, housing, jobs, etc., is they see that as being more significant than the economic and social benefits. So here again, I've listed some of the benefits there. I know I'm running out of time, but you can see again a visual of the transmission lines in the rural areas, and this is what people are very much against, including also noise and vibration during construction. The increase in jobs during construction is also going to be significant, as shown in this graph. But again, we have a difficult job ahead to convince the population. I just want to talk quickly about Endeavour using other technologies for sustainable development, such as drones for power line inspections, and also using batteries for firming power in remote areas. This is the first one that we've installed in a beautiful little place called Bawley Point. You can see all the beaches. It's very, very remote, just 250 kilometers south of Sydney. It's the first one. So it's a community battery. So people generate rooftop solar and share the power that's share the storage in the community battery for their general use. So Bawley Point is up here. And the other big area is we're putting in batteries in substations wherever we have spare land, again, for firming power and to stabilize the grid. And of course, diversity and inclusion. This year, we had 50% women apprentices in electricity trade, so we're very committed to diversity and inclusion. And finally, sustainability bonds. So this a lot of the funding is coming from bonds where performance to sustainable development markers reduce the interest rate by a few points. And we raised a landmark nearly $1 billion with the sustainability bond. So that's my conclusion. A last slide showing the impact of engineering on each of these sustainable development goals. Thank you.
So, many thanks, Dr. Marlene Kanga. This is the end of this first part. We have now a break. I was informed by the organization that considering there is a small sliding of time, next section will start at 4:45 sharp. Please be here at 4:45 so to see if we are able to finish in time. Thank you very much to the speakers and to the audience here and elsewhere in the world.
How did we get here? We progressed. We empowered. We innovated. How did we do it? With engineering.
To World Engineering Day. Now here with me is José Vieira, World Federation of Engineering Organizations immediate past president. Hi, in your opinion, what are the main drivers of the energy transition?
Well, we have a very serious problem in climate change consequences, and we must avoid or at least reduce the emissions of greenhouse gases. So these emissions are very related to the sources of energy that we have now, mainly coal, oil, and we must face this problem, changing the sources of energy, mainly what we say about the transition from coal and from oil to another sources of energy, renewable energies. This is the problem.
How urgent is transformation energy systems to be more reliable and resilient?
Yes, we have this problem now because our technology is developing a new renewable sources of energy, and these renewable sources are mainly intermittent, mainly solar energy or wind energy. So we have this kind of sources of energy when we have wind, when we have sun, and the industrial production and the common consumption rely on some continuity of supply of energy. So these are a big problem, and of course we have other sources that are more permanent, like hydro energy, hydropower energy, or nuclear energy, and so this is the main, I'd say, challenges for engineering and engineers to solve this problem of the basic problem that is the climate change consequences of our planet.
Thank you very much.
Está ok? Respondi bem?
Everything. Now we have Luís Mira Amaral, former Portuguese Minister of Industry and Energy, Portugal. Tell me, what are the main costs of the energy transition?
Well, we must take into account that we have an economic dimension of the energy transition, and sometimes people are delighted to speak about energy transition, and then they forget the costs of this transition. This is a huge challenge. It's not an easy transition, and I feel that, namely in Europe and the United States, this transition is conducted by political power, not taking into account economic realities. So we have made big mistakes in such an energy transition, and this will have high social and economic costs. So in my explanation, I tried to explain the economic sustainability of the energy transition. Explain that we cannot only have an engineered approach. We are engineers, but we cannot forget the economic costs of the energy transition.
It's well known that electric cars are expensive and Portuguese people don't have financial capacity to buy them. How can we solve this problem and balance the industrial advancement with this issue?
Well, this is a crucial point because Portugal is not the most developed country inside the EU, so we must take into account the economic costs for the people, for the families, and for the economy, namely for small and medium enterprises. Sometimes they don't have the money to invest heavily in the energy transition, so we must take care about it, and the government must support many times this energy transition. And the government has a lot of European structural funds to finance the energy transition. So I don't say that we have a huge financial problem, because happily for Portugal, we have a lot of money from EU structural funds that can finance this energy transition. But if we are not inside the EU, and if you don't have money from European Union to finance our economy, it would be quite impossible to finance this energy transition.
Thank you very much. And now I am talking to Seng Huan Tan, World Federation of Engineering Organizations President-elect from Singapore. Hi, what type of inheritance do you think you will inherit in this position?
I think it's to encourage more younger generations to come into engineering. I think always a global problem. So I think that is during the periods we'll try to get more young engineers. Yeah.
How do you evaluate the country's strategic considerations for decarbonization policies in energy systems in general and in our own country?
I think we are going into all renewable, and we're getting more technology to improve the renewable energies productions. Yeah.
Okay, thank you very much. Thank you. Now with me is Marlene Vaiani, Secretary General, Conseil Français de l'Énergie, France. Your country invested strongly in nuclear energy. What caused your autonomy in this matter? Can you please explain what was done in this investment?
Sorry. So for France, nuclear energy has always been a strategic energy. Currently, we are operating a huge park of nuclear power plant, but we are also investing on two kinds of reactors. Small modular reactors, and there are a lot of small startups, but also a company created from EDF, which is New World. And there is also a big, massive power plant, nuclear power plant, which is called EPR. And we are developing it in China. There is also the technology plant in Finland, and also, of course, in France.
What are the next main goals in France for this energy matter?
We would like to develop more nuclear power plant because the need of electricity, low carbon electricity, flexible electricity is huge. And of course in France, but also in Europe. And that's why we need to accelerate and to develop more of that.
Thank you very much. So it's all for now. Thank you.
Well, hello again. Good afternoon. I'm here with a Portuguese engineer, a woman, and she's Lídia Santiago, Vice President of the Portuguese Engineers Association. And tell me, Lídia, hello, good afternoon. How has the Association of Engineers supported women's participation in engineering since the beginning, because you're here for several years and till now?
Okay, good afternoon. I am Vice President after 2019, and before I was in 2018. I made here for the first time an event of women engineers of INWES, International Network Women Engineers and Scientists. And in the 8th March 2018, I had here women engineers from all Europe. And it was the first event of women. After that, I was Vice President in 2019. And now, in this mandate, we had created the committee, the women, the Women's Committee for the Equality of Gender. And also our president, when he had candidated, he had submitted to 2024 to be the year of the gender equality. And we have 3 events in Portugal. The first one is in Coimbra in 21 de Março, 21st March. The second one is 21st June in Porto. And finally in October, and 17 October, we have here in Lisbon.
It's a great work. Congratulations.
Not only, but in 2022, we had submitted our candidate to have in Portugal the 16th encounter of women engineers, Ibero-American women engineers, architects, and agrimensors, that are the geographical engineers. And we had gained, we came back to Portugal this encounter. Then in November, between 18 and 21st November, in Laboratório Nacional de Engenharia Civil, LENEC, we expect to have 500 people. It's an international congress, but speak in Spanish. And we wait to have here men and women of 27 or 28 countries, because we invite also the people of Cabo Verde, Angola, Mozambique, Brazil, because the event was only the South America, but Spanish South America. And now we grounded it to be also with the Portuguese language.
It's a long list, and thank you so much for your work. What's the importance of the World Engineering Day happening in Portugal for you?
It's important in all the world because the work of the engineers, it's not visible. The women are not visible, and the men also. Because when I go to the schools, I search always, I quest always to the pupils. Who is not consumer? And the pupils are very intelligent because nobody say anything. They know very well that they are consumers. And is that engineer is always with consumer. All what we consumer is engineer. Then to give knowledge to the engineer and the engineers is very good for the society, because the people, the society, doesn't know which is the role of the engineers. The society doesn't know, and the political people doesn't want to know, because they decide things only, political decisions, and not technical decisions. And sometimes, and we see all the world, the political decisions sometimes are not the best, but it's so.
Thank you so much, Lydia. Very straight to the point. Thank you. Thank you so much. And now I'm here with Ania from Ghana. She's a Ghana engineer. And at first, I would like to know, I think it would be very interesting to know if you face the same problems in Ghana that we face in Portugal, because we have a lot of lack of labor here. Is it the same in Ghana?
Oh, for Ghana, what we are experiencing is also the switch transition to the sustainable renewable energy sources. And when it comes to labor, we have a lot of skilled labor. It's just that we don't have much employment. And so that is one of our challenges. But in this conference, I came in with 5 female engineers. We are representing the Ghana Institution of Engineering, and I've also recently taken up a position as the Women in Engineering Chair for the World Federation of Engineering Organizations. And so we believe that engineering solutions that will provide provide a sustainable world is based on gender equality, inclusivity, and then diversity as well. And so as the Women in Engineering Committee Chair, we have a number of strategic initiatives that we are taking to be able to provide a sustainable world, making sure that we don't leave anyone behind. And one of the initiatives we are doing is to make sure that we generate interest, we promote female in engineering, and we are catching the young ones through a competition that we are doing. It's called the Science, Technology, Engineering, Arts and Mathematics competition. It started at the African level. We are looking at it globally, where we catch them young. We get them to get involved in competitions towards addressing climate change issues in the world. And so we have targeted catching the children young right from the ages 5 years, and they have been coming up with competitive solutions, and we have been giving them awards as well. This is to generate engineering in them, generate their interest in science, engineering, mathematics at the younger level, so we could close up the gender gap in engineering. And so those are some of the initiatives we are also taking up. Also, one major thing that we are also facing as women in engineering is to retain the females in the engineering sector. Because of the difficulties in the working environment, most of them study engineering and then they go out to other fields. And so we have come up with a certain initiative that we are expanding globally. And one of those initiatives is to recognize their achievements and to showcase their achievements through the organization of initiatives such as Shehu. So every female that has achieved something the first time is recognized. And also every female that is an influential female engineer is also recognized as well. We are also working with the female engineering students and the young engineering female students to make sure that they participate in the WFEO hackathon, so that they can also, it can generate their interest in innovation, and then we can produce a sustainable world that covers everyone, takes the perspective of women into consideration to solve our problems in the world. And so that is what we are trying to do.
Oh, and that's a lot of work there.
A lot of work.
Thank you.
So my role here is to make sure that I'm actually putting all the females together. You saw us, we just took a picture. We've created a platform where we can engage with each other, so that at the world level, everyone leaves this conference going to make sure that they can make an impact in their various countries.
And I'm sure they are going to. Thank you. Thank you so much.
Thank you.
So I'm glad to introduce you to another woman, and this time she's a Portuguese student. She studies engineering, and I'm very curious to know what she has to say about this conference today, because you are still a student. Why did you come here? What are the conference interesting for you, all the participants?
First of all, good afternoon to you all. I came here for several reasons, namely my thesis, which is based on the sustainability theme. And I'm studying the social responsibility in mechanical engineering, which is my specialty. So based on that, I decided to explore even more, and learn with several experiences, since we have several guests from all around the world. So I guess that...
Can you introduce yourself, because you're still young? I want to know your name, would like to know your name, and what kind of engineering do you study?
Yes, so I'm Catarina. I'm in my final year of mechanical engineering. Inside mechanical engineering, I study materials and manufacturing. And I'm at the moment doing my dissertation in the matter I said before.
From your experience, do you have many female students as you are, many colleagues?
The numbers have been increasing, of course. 5 years ago, when I entered, we were 120, the total, and we were only 30, 40 girls. So, but with the years passing by, it's getting better. So I'm all for women in STEM.
So thank you, Catarina. Good luck. Thank you. So my fourth guest, she's also a woman. I'm very happy about that. Welcome, Mariana.
Thank you very much.
You are a member of the Portuguese engineering order and also in Angola.
Yes, I started in Portuguese order, then I moved to Angola order. I'm in both orders.
Okay, and is it very different to work in Angola in the engineering area and here in Portugal?
I couldn't say that because I'm working in Portugal. I haven't started working in Angola, but it's a bit different in terms of engineering because in Angola it's more about the after project, and here we do actually engineering. In Angola it's more a consent project.
And how do you find this conference today? Do you think it's interesting for you?
I'm delighted to be part of this because I want to be part of education engineer, women engineer. So it's amazing to be here actually.
This is our year. How would you captivate other women to be here and study engineering? Because the numbers are increasing, but we still need more women here working in engineering, this area.
I have been thinking about that. Maybe I will start with girls who likes mathematics, physics, chemics, and maybe who likes to innovate, to start new things. I've been thinking about it, but I don't know yet how to do it, but I'm thinking about it.
What are your main worries now in this area?
Education, education, yes. And traffic, road engineer, because it's my area. And I want to do that in Angola. I want to be part of the team who will do the studies for traffic engineer in Angola.
Thank you, Ariana. Thank you. We're back to the conference now.
Okay, dear colleagues, good afternoon. We are in the sharp hour, a little bit late. Let's begin the second part of our conference day. I hope that your attention is still alive and full of energy, renewable energy. I will call our colleague engineer Ania López, is the WFEO Executive Vice President and also member representative of Consiglio Nazionale degli Ingegneri Italy. Ania López has a double degree in mechanical engineering in Cuba and Italy. She is a consultant as project manager for energy engineer for the European project Next Generation EU in the authorization processes for all renewable energy plants in the Lazio region, Italy. From 2020, she has been chair of the WFEO Awards Committee and member of the committee's support and review working group. Since 2013, she was the delegate of the Italian National Council of Engineers, CNI, at the WFEO, an active member in the committees on women and energy. From 2011 to 2022, she was member of CNI, Ministry of Justice, and of the Foundation Board of the National Council of Engineers. She will take the floor to talk about challenge of renewable energy for sustainable agriculture regarding the SDG of the 2030 agenda. Please.
Thank you for the organization, for the Ordem dos Engenheiros of Portugal, WFEO, the president, past president, and the colleagues present in the room. The title of my presentation is the challenge of renewable energy for sustainable agriculture regarding SDG of agenda. And I would like to divide in three parts. I respect the rules. First, announce of the professor, because I would like to introduce the information about renewable energy. Okay, this is the introduce. I would like in the first part, the typical of renewable energy use in agriculture, an overview of agenda of the sustainable development goals, like of agriculture sector, importance of renewable energy to achieve sustainable agriculture, the challenge of engineer in the agriculture sector. In this case, this question, first probably is better this. Okay, no, it's the same. I would like to have a question and organize a challenge of idea. And the third, I would like to show the best practice, Italian best practice in agrovoltaico. This is a system created for Italian country, okay? Beginning. This is a background on the renewable energy you know very well, the solar energy, wind energy, biomass. The source is operation park of wind farm in Italy, in Sardinia. And the first is the largest photovoltaic park in Italy, in Feyo, in the south of Italy. Biomass, this is the electrical or thermal energy from Gudi and in Cuneo, north of Italy. The other is hydropower. This is the Centino Sassoferrato Macerata, the center of Italy. And the last, geothermal energy, Lardello Geothermal Power Plant in Toscana. This is a very important region for geothermal in Italy. The next is the importance of renewable energy achieved to sustainable agriculture. This is 2.7 and 30 and life on land. This is the most important and the idea with relationship with agriculture and put for what is the relationship engineer, agriculture and sustainable energy. This is the second part, the most important challenge. I would like to have a question, the most important question. Now, what may be the challenge of engineering in the agriculture sector? This is my research of the university. I continue to study in university. And now I have a study and research with sustainable and specific in different sector relationship with agriculture. And the challenge today, very quickly, I would like speak about the idea and focus with technology adaptation, resource constraint, climate change, environmental sustainability, infrastructure development, mechanization and labor issues, data management and digitalization, policy and regulation, and socioeconomic factor. The point of view of engineering. The first, this is a lot of information, but I would like to concentrate the information with the University of Vienna. This is the slide that presents a study where the company challenge of agricultural plan with the reduced water, pesticide, energy, and increased greater adaptation and climate change, and maintain soil health and greater increase of crop and through the objective of agenda. This is a photo with a technology, and this is the model of agri-food sector and carbon footprint. This is the concept. This is a point of view what encourage farming and the point of view of engineer. Engineer must design technology that are user-friendly, affordable, and adapting to local conditions to facilitate adaptation. The second is challenge resource constraint. This is a particular, in this case, agriculture engineer projects often operate in resource-constrained environmental where access to material, equipment, and skilled labor may be limited. Okay? In this case, the engineer must find innovation solution. This is the example. For example, this is in this case, the sample with Feyo will coordinate in different areas of the region. Will coordinate agriculture and social intervention to study conducted by European. The second, which reveal quantity of food we throw every year, and who make company, for example, Orange Fever Ferragamo. Ferragamo, this is the most important company of the fashion in Italy, and use the orange peel, okay? The waste food reuse again for produce outfit in this case. Third, this terrible situation, climate change, and environmental sustainability, okay? The climate change poses significant challenge to agricultural system, including unpredictable weather patterns, water scarcity, and land degradation, and included period to intense drought and landslide. What the engineer have? This is a real photo to Italy, Venice, Tuscany, and Milan. And the last, this is a map of Italy, but the company to the ISPRA, this is the organization to the government, that have analyzed the map will find the landslide area will deeper with color, a different color. The green and our color, green color is Po Valley, okay? This is you analyze the map, this is a terrible situation, okay? The engineer must develop resilient technology and practice the mitigation climate risk, preserve a natural resource and minimize the environmental impact with a period monitoring and control action on the state of the area most prone to landslide, avoiding illegal construction in unsustainable area and high risk of dismantling and create natural barrier to contain it. The next is challenge to infrastructure develop. In this case, and I would like to show two different situations. The first is present the Italian reality famous and produce the sugar almonds. This is confetti in Italian. This is very famous for a party and wedding. And this is this production use a green production and use renewable energy and environmental impact is very reduced in the process. And in this case, why the future worker and startups are game change on sustainable cares and show a different point of view in Braga sustainable care choice, sustainable agriculture and food system for analyze a different step for analyze the infrastructure and develop. The engineer play a crucial role in design and implementing infrastructure projects that improve access to markets, input and service for farmers. The other is mechanization and labor issues. I showed a different photo for biophysical, economic, and sustainable, and the mechanization. But the problem in this case is that the mechanization in agriculture is useful tools of sustainable development, but with the an hours agriculture vehicle consume fuel. And trying to reduce the environmental pollution, this is a bigger problem and it's necessary to introduce a new technique. An agricultural mechanization explained, this is the research, and I put the source and what is the effect of the employees, the effect of the activity and efficiency and income distribution and environmental impact. I think that the engineer must balance benefits and mechanisms. There is a growing concern about the deployment of rural labor and impact on livelihood. This is very important to smart farming, the data management and digitalization. This is a challenge. The agriculture sector is increasing resilient and data-driven technology, such as precision agriculture, remote sensing, and digital platform. And you use different instruments and engineers face a challenge to release the data collection, management, and analyze, as well as concern about data privacy. Privacy, this is a very important concept, and security for increase and put the different sector that develop the smart farming, sensing technology, software application, and communication with the system, telematic position technology, hardware and software system, and data analyze solution. This is a policy and regulation. I would like to put with example of a community European and the agriculture engineer project as subject and complex regulatory and environmental can vary widely between region and country. This is a sample and the document the future European Union agricultural policy. And this is very interesting, the subdivision and analyze what is a different position. The agriculture engineering perspective and subject to complex regulatory environmental that I can vary widely between different areas in the same country. For example, Italy, north or south is very different. And the Commission Agriculture and Policy 2023-27 has adopting a set proposal to make a European climate, energy, transport and taxation policy for reduce the greenhouse. This is very important by emission 2030. The last, this is a socioeconomic factor, the engagement cycle, economy circulate, and talk about with the people, with the farmer, with the company. This is very important. When I remember when I say, when the presentation of Canada, you remember Canada, the Agenda 2030, the master and the course, and show when the professor, students talk about with the people and the country for develop together with a strategy. This is very important. In Italy, this is the example with a slow food. This is a global movement which activities organize and discuss a different thematic and create together the solution. The engineer, this is a fundamental role in this activity. Now, this is the third part. This is annual and monthly production of photovoltaic system in Italy. This activity to develop by Energy Service Manager, ESE, this is the company of the government. And you analyze an increase and the period. This is increase and the most important period to produce is in particular July. This is the more hot in Italy and the highest production. This is increase. But the problem now is, for example, in Italy is the aspect of architectural and environmental impact with environment. And this is the problem with authorization because the process is very, very long process, 2 and 3 years of one process for wind park, for example. And this is terrible for the company and it's necessary to create the balance. This is the sample in Italy information to producibility of wind power plant 2022. In different regions, the most important region in Italy of wind farm is in south of Italy, Puglia, Basilicata, Calabria, Campania, Sicily, and Sardinia. This is the most important. On increase, Puglia, this is the most important production of power of wind. This is the same company that organize and produce. This is open and in English, this information. This is in my city. It's very near Tarquinia Solar Park in Viterbo and Pianzano. This is the best practice of Italy. Is a big, important solar park and Pianzano. This is a concentrate, a lot of implantation with a wind farm in one region. But this is the most important. But it's necessary to create a map for analyze because it's very difficult to identify because the process for the government is very, very long. This is a conclusion very quickly. Yes, because it's a lot of information. I would like to have the largest floating photovoltaic plant in Europe is in Portugal, in Alqueva. This is the hydroelectric dam basin. I would like to conclude with 3 important points. The first, sustainable agriculture is essential to address interconnect challenges such as hunger, poverty, climate change, and biodiversity loss. Second, by adopting sustainable practice, agriculture can become a powerful catalyst to achieve, multiply sustainable development goals and build a more resilient, equitable future for all interdisciplinary collaboration, engineering, agronomy, and other specialization, a stakeholder involvement, an holistic approach, and economies that consider the social, economic, and environmental agricultural development. The third, the engineer play a crucial role in driving innovation and sustainable growth in agriculture sector. And I would like to conclude with a quote of Pessoa. What is distinguished people from each other is a strength, and to make it or the lack faith to do it us. It's necessary to have the difference. I would like to show the landscapes. This is a beautiful Praia da Reina. My pronunciation is not good, but the turquoise sea is beautiful. But the engineer work, okay? And understand in this photo that the role of engineer, okay? Thank you so much for this opportunity.
Thank you, Ania, for your message concerning technology and agriculture. Next, we have another presentation, the future of nuclear energy in Europe. I will call Engineer Pedro Sampaio Nunes, former Portuguese Secretary of State of Science and Innovation of Portugal. Pedro Sampaio Nunes is graduated in civil engineers with a specialization in energy from the Order of Engineers. He was Secretary of State of Science and Innovation of the 16th Constitutional Government of Portugal. In the European Commission, he was Director for Internet, Network Security and General Affairs, Director for Information Society Strategy, and E-Europe, Director for Conventional Energy and Director for Energy Technologies. Please, colleague, the floor is yours.
Well, thank you very much for the invitation, and I was extremely pleased to see the floating PV project in Alqueva that was conceived and developed by me some 9 years ago. And after, with the change of government, it was picked, and the government decided to launch a public tender and not develop the memorandum of understanding that we have proposed to the Alqueva Dam. But it was a very nice project that shows how renewable energy can be well integrated and how we can use intermittency, so the variable nature of photovoltaic energy, to adapt to a variable use. So the problem it is when these don't match, and this is the reason and the rationale for my presentation. My presentation will be extremely facilitated because in the previous presentations of Professor Clemente Pedro Nunes, my good friend, and Professor Luís Mira Amaral, my good friend also, they present all the arguments why you should use nuclear energy. They only missed the last step of saying we must have nuclear energy also in Portugal. But I will try to do that step with some arguments. So, on these graphs, I will show you this is based on research done by the Bank of America on their recommendation for investment. They are recommending, they are saying that nuclear is now a necessity, and these show the high cost of managing renewable intermittency. How it was said already by especially Clemente Pedro Nunes. So if we can compare on the first graph the cost of nuclear, and here I'm using the costs for the United States that are considerably higher than other places in the world. And we had either carbon taxes or batteries costs in order to manage this intermittency, we will see that nuclear becomes, even for the United States, a better solution, a best option than the other alternatives. Here we can see these costs, so the full cost, because normally we only consider the levelized cost of electricity. This is the normal metric that is used to compare different technologies. But if we consider now the full cost, so the cost of balancing the system, of increasing grids in order to match what I think also on the presentation of Marlene Kanga, it was very clear. The resource for wind and the resource for solar exist where it's best. So in Portugal, on uphills, and for solar in Alentejo, where we have the higher radiation. So increasing or depending only on renewables, we need to extend grids in order to collect that resource, after transport it to the storage on dams, that was very well explained by Clemente, and finally, grid connection also to put on the consumption. So these increase enormously the cost of the total systems, and we can see here the costs for wind and solar, either for Texas or for Germany. Texas, Germany, South Australia show us what will be the result of this policy that was inaugurated by the Germans, the energy event, that decided out of Fukushima that they should shut up, phase down their nuclear power plants and replace it by something based on all renewables. This is not feasible. Today we are verifying it's not feasible. There is no storage means, the costs are huge, and we cannot take this step when we have an option that is much more competitive, safe, and does not imply the huge footprint in terms of materials and critical materials. So these huge mining needs due to low energy density of renewables, so the first costs are due to intermittency. This is due to low density of renewables. So in order to produce one unit of energy with nuclear, we need much less materials that we need for the same amount of energy produced by renewables. So the comparison that is now studied is something like between 14 to 20 times more materials that we need for renewables than for nuclear. And for space, we need something like 100 times more space than we need for nuclear. So that's the reason why these huge amounts of materials that are needed, mining, that takes a lot of time to install, and public acceptance also to be displayed, put a big question mark on all the scenarios that are being developed, even for the International Energy Agency and for the European Commission, that were estimating that we could achieve bigger decarbonization with using mainly renewables. This is being realized that is not feasible and is not cheap. So that's why we are moving for the interest, the new interest in nuclear. Let me also show something that is very interesting. On this slide you can see the type of materials that are needed on the different technologies, and who dominates today not only the extraction, if not extraction, the processing and the end products. So Europe, that only represents 7% of the emissions, being Portugal only 0.1%, decided some years ago that would lead the energy green transition in order to dominate all the critical technologies. What is the result today? The result, it is that where the problem will be solved, and this is mainly China, 1/3 of the emissions, Asia, 55% of the emissions. This is where it will be saved. And who's dominating all the technologies that are critical for the green transition? China. Big compliments to our colleague from China, because they are dominating wind power, they are dominating solar power, they are dominating batteries, they are dominating electric vehicles. And so we can risk we were depending on Middle East for hydrocarbons in the 70s and 80s when there was the first oil shock. We could move away at the time with the big development of nuclear. I will show you the numbers. And we move after for the dependence of natural gas from Russia. We risk to depend in our friends of China on technologies, materials, and everything, because they have another critical mass, and they have developed a very clever strategy for dominating all these critical technologies. And they are also today dominating nuclear technology, because China decided to buy the best French reactor, the best American reactor, the best Canadian reactor, and after decided to make their own homework, and today they are prepared to export a very competitive, very good, very sound, very robust nuclear reactors that they are building like no other member in no other country in the world in China. So this is a red flag for Europe to realize if our strategy is correct. This red flag was already transformed in a cry from the industry. We have very recently, in 20 February, there was a major meeting in Antwerp with the major industry of Europe saying, stop, let's think what we must do and not continue this run against the wall. So, nuclear on the opposite, contrary to renewables, because it have this very high density of energy, the needs for minerals are much less important, even for the aim of multiplying the installed capacity at a horizon of 2050. Another sign that raise another red flag, it is with the trillion of euros invested in Germany on this energy vendor, their emissions are much higher even today than the ones of France. So we can see here that the dirtiest, Poland, that already discovered this and is now preparing, Poland has no nuclear energy, decided to enter in a very ambitious program of nuclear energy, combining conventional reactors, 1 gigawatt size, with small modular reactors that are being developed, not yet commercially available. They decided to enter on the nuclear club. But Germany is the second worst performing in terms of emissions, as Spain, and these are the champions of renewables in terms of deployment. And Portugal does not also appear very, very well on this picture against Sweden or France or other countries that have this very virtuous combination of nuclear and renewables. Nuclear for base load, renewables for variable load. This is what, for me, is the example that we must copy. And with engineers advising our government, but engineers, not politicians that say, perhaps this is a good idea because people like it. But with engineers, make the strategy that either Luís Amaral and Clemente were requiring. We need to have a strategy well done, with serenity, but with engineers to make all the calculations and some economists also. So, moving, we can see here what I told you, and this is another sign why people are now moving a big interest for nuclear. Because in 10 years' time, after the oil shocks, France showed us that could reduce from 55% of dependence on energy, on electricity production, that was dependent 55% on fossil fuels, to 10%. In 10 years' time, this is not feasible with renewables. This is only feasible with nuclear power. So this is the reason, or this is the theme for my presentation. What is the landscape today in Europe? The landscape today in Europe is basically what you can see here. The darker countries, it is where there is nuclear energy. The lighter, where there is no nuclear energy, including Germany that phased out all their 14 reactors. And here in the east, the same thing. But in the meantime, France, very recently, I would say last year, decided to take the lead, and against the policy that was decided in the beginning of the government Macron, with another minister that wanted to reduce their percentage of nuclear for 50% and abandon a lot of manpower and know-how that is essential, supply chains, to keep this fleet. They decided to make a U-turn, and now is leading an alliance with Belgium. The same happened. Belgium had a government decision to abandon nuclear energy, now recover, make the U-turn, and is recovering, is investing now again in nuclear. Bulgaria, Croatia, Czech Republic, Estonia, Finland, France, Hungary, the Netherlands, Poland, Romania, Slovenia, Slovakia, Sweden, and United Kingdom as invitee, and Italy as an observer. Italy decided also to look with big interest on nuclear. And this shift also happened quite recently, and because of the pressure led by France, the Commission decided to include on their green taxonomy, so allowing investment in nuclear energy, and decided more recently to promote the European Industrial Alliance on small modular reactors. Small modular reactors are a big hope for nuclear in order to have lighter, smaller reactors that could be introduced in the grid in a more easy way. So, what are the objections normally against nuclear? The objections are, and we have listened these tens of times, the cost and the construction time. So if you will see the construction time and you evaluate all the different last reactors that were built on the last decades, we can see that was the medium of time from concrete to commercial operation is around 60 months, so 5 years. We have some big delays with a family of the French reactors of Shehu that were on the 90s, because there was a problem of conception that had to be resolved. And you have also the problem with some reactors that were built in the Soviet Union when there was the problem of the fall of the Soviet Union. And here in the end, we have what is called the first of a kind in Olkiluoto in Finland that I visited with Luís Amaral 10 years ago, and was already ready, but that was within a big legal fight between the promoter and the constructor and Flamanville. So Flamanville and Olkiluoto, because this is this very complex and very big reactor, EPR, the European Pressurized Reactor, create a bad name for nuclear because the cost overruns and the length of construction, it was really very big. But in the same time, China was building with 5 years' time, and South Korea 5 years' time. And one country that had never nuclear, that had a lot of petroleum, a lot of gas, a lot of sun, a lot of wind, the Emirates, the Arab United Emirates, decided to launch a tender for 4 reactors. And this tender was won by South Korea, with a big surprise and big disgust from the French. And the last was connected last week. So the fourth are now producing energy in the Emirates, ensuring the base load for the other sources be responsible for the variable load. So this is the way to go, in my view. If we will consider the other opposition today, that is the cost, we can see that from the last export contracts, we have here all the contracts, so Pakistan, India, China, United Emirates, Belarus, Pakistan, Turkey, Bangladesh, Hungary, Egypt, UK. The Financial Times made a synthesis of all these costs, and they arrived to the conclusions that 85% of all these new builds are below $5,500 per kilowatt electric. And 40% between these 85 are even below 3,500. So this is extremely cost competitive. And if we will use this in, let's say, a graphic that will take these costs, so from 6,000, from 2,500 to 6,000, we consider that 2,500 is the cost announced in China for instance, the Hualong 1 reactors, very, very competitive, or in South Korea for the APRs 1,400, the ones that they sold to the Emirates. So we can see that depending on the net discount rate, because these huge investments upfront are very, very dependent from the interest rates. So we can see that we are dealing with the cost of megawatt hour between 20-something, so 30 euros per megawatt hour, until 122, that is the case, for instance, of Hinkley Point C in the United Kingdom, another reactor that came always as showing the example that nuclear is not possible. This is what we listen from the critics. So we can see here that really can be extremely cost competitive, and a tender or a request for proposals or for information organized in any country could give us a very good surprise in terms of costs. So, in the other end, we are also looking for the stability and reliability of the source of the fuel. And today for uranium, we can see that more than 50% came from very reliable sources, like, for instance, Australia, the biggest. So another very difficult problem for me to understand it is how Australia has not nuclear energy. It's so obvious. It's so obvious. You have everything. You have the everything. And Kazakhstan, Canada, China, Brazil, South Africa, Namibia, and others. So, moving to conclude my presentation, it was approved by the pressure of France and the Nuclear Alliance on the proposal from the Commission that is now already approved by the Council in a trialogue with the Parliament, a regulation on a framework of measures for strengthening Europe net zero technology products manufacturing ecosystem, the Net Zero Industry Act. On this, the list of technologies is very clear said, nuclear fission energy technologies, including nuclear fuel cycle technologies. What consists this framework? This framework is part that is speedy game procedures, licensing being much more speedy, because this is also a barrier for renewables. As it was said, licensing a renewable park can take years. I have the experience with a very, very clear, very obvious, taking 5 years to be only accepted, and also facilitating the financing. So I think that I will conclude with this last decision that was so important for the future of nuclear in Europe. This will be a strong lever to advance nuclear programs, both for conventional reactors, fast breeders, that fast breeders will open the practical, will solve the nuclear waste problems by transforming waste in new fuel. So it's absolutely incredible result from this fourth generation. I would say that France had one fast breeder, Super Phoenix, that was dismantled by a political decision, unfortunately, and small and medium reactors. In almost all European countries, the debate on nuclear energy has been lively and conclusive, with growing support from public opinion. Even in Portugal, we have a poll that says that in every 3 people, 2 support nuclear, even in Portugal. The same for Germany, and the same for a lot of countries. Even in Denmark and Norway, the champions of renewables, Denmark because there's a lot of wind, and Norway because there's a lot of hydro, the debate on nuclear power is ongoing. Countries without nuclear now have plans to install it, such as Poland and Italy, and because I see that we have some friends from Africa, the International Atomic Energy Agency is collaborating with 21 countries of Africa in order to bring nuclear to Africa. This is not exclusive of the Western world. This is energy for the world. So, countries that have decided to stop or freeze nuclear power has decided to increase their use of this energy, such as Sweden, France, the Netherlands, Belgium, and United Kingdom. Finally, countries where the current government resists and intend to maintain the current policy of all renewables, such as Germany and Spain, will see their policies change when the opposition takes office. The opposition announced already that they will change because this is a completely absurd policy. Only countries like Austria, Portugal, and Luxembourg maintain a taboo on the subject. In Portugal, for the first time, some parties, some political parties, have included in their electoral programs the need to study this option. Thank you very much.
Thank you for your brilliant argumentation for supporting the nuclear plants, power plants. Thank you. Now we have another communication called Adjust Transitions to Sustainable Energy and a Net Zero Future in Emerging Markets, the case of Africa. I will call Mr. Engineer Martin Manua, WFEO Committee of Engineering, Capacity Building Chair, and ZAIDG, Consulting Engineers, Zimbabwe. Engineer Martin Manua is an electrical and energy consultant engineer and is currently the Managing Director of Zimbabwe Africa Infrastructure Development Group, ZAIDG, a company that specializes in engineering procurement and construction management. Martin teaches part-time engineer graduate students at the Zimbabwe National Defense University and has taught MBAs and MBLs at the University of Zimbabwe and Bindura University of Science Education, respectively. He is the past president of the Southern African Federation of Engineering Organizations, SAFEO, and the Zimbabwe Institution of Engineers, ZIE. He is the immediate past president of the Federation of African Engineering Organizations. Please.
Thank you. Thank you very much for the generous introduction. I think this is a very interesting time, as most of us have been here all morning. So I will try by all means to do justice. I would like to invite all of you to Africa. The next time we are in Rwanda, for the WFEO council meetings. Come and enjoy the hospitality, and when you come to Africa, please pass by the Great Victoria Falls, because if you have never been to Victoria Falls, you have never been anywhere. That's what they say. So thank you so much. I had to make my points 11 so that they represent a football team, because I am an admirer of Ronaldo. So 11, number 7, net zero carbon neutrality is Ronaldo's jersey. Now into business. What is your carbon footprint? I want you all to remember that objects, as they appear on the view on your mirror, they are closer than they really appear. So the dangers of climate change and the risk is just behind us. So I will contextualize my discussion into our African context. Yes, Africa is bursting with possibilities, and it's endowed with natural resources. My friends from DR Congo, with the Inca 1 to 3, can supply electricity that will be used for the rest of, for all of Europe and Africa. Just the hydro system, if they are developed. My friend Gustav, you can confirm this. And there are many other sources that we have, and we have 40% of the global reserves of key minerals for batteries and hydrogen technologies. Lithium, all those, cobalt, all those are in there. Africa, according to His Excellency, the President of Kenya, President Ruto, he says Africa is demonstrated that climate change, energy access, poverty, development, and conflict are tightly connected and are different dimensions of the same phenomenon. He further says he believes by becoming more assertive and pursuing a climate and development agenda through unified approaches, Africa will be able to mitigate the climate emergency and propel itself to prosperity. Wise words indeed. As an introduction, it has been demonstrated since morning that energy is crucial for all life and quality of life as we know it. Again, it is important for the development of all countries. Therefore, I'm not disputing that net zero transitional pathways for Africa are important, but we are saying they should reflect local resources, viable development pathways, and other local specific requirements. Why am I saying this? It's because most of the countries advocating net zero are from the global developed West. And it's important that, of course, scenarios differ. You will see that our emission levels as we go into the presentation in Africa, estimated by the IRENA group, they are between 3 to about 3.8%, 3.5%. And I'm also seeing Europe is low, 7%. But there's a group of 4, China, India, Russia, what's the 4th one? And the United States, they're at 55%. Yeah, so the rest of the world share the remaining 30 or so. So it's a very good context that we need to consider. You will see as we conclude what we propose. Again, the SDGs, especially Goal 7, must be respected, and as Africa, we are keen to also follow the renewable energy pathways. I will also discuss how the micro-nuclear grids can also assist African countries to gain that energy requirement that we need so much. Again, like I said, the earlier phase of the net zero initiative is in developed countries focused on enhancing economic performance and decommissioning thermal stations due to the carbon emissions regulations. Previous speaker has just read one. But some countries in Africa have nothing to decommission at the moment, because you see the electricity penetration is at 20%, 40%. So it's sub-Saharan Africa especially. So I'll give that context. It is against this background that Africa has this abundance in unutilized energy resources and is the smallest share, like I said. I've already discussed the Big Four, and Africa, with 54 countries, is estimated at 3 to 3.8%. So we are still energy poor, and as such, we need to make energy access while also considering and balancing the climate change actions. If you recall my quote from President William Ruto, that let us ensure that we intertwine how we then develop just pathways that also address those that will not, like President Mashetile of South Africa, Deputy President, said that we cannot transition in darkness. We have to build something and then transition. But then again, that is debatable. I will also look at what is it that, we looked at the 54 African countries, and the following policies are giving some of good energy practices. These are climate change mitigation and adaptation systems in the energy policies, energy transition, carbon neutrality, and net zero. We have to differentiate those and how they can be best developed in Africa. Again, energy poverty and energy access issues are very important. Battery energy storage systems are also very important. I've seen some excellent demonstration from past President Marlene Kanga, where they can be deployed in rural communities, as well as they can intermittently be used with other sources of energy like wind, hydro, and the storage will make sure that we will be in lights when there is darkness. There are a lot of challenges, of course, and I would like to address 3 challenges. One is energy accessibility to some segments of the poor rural population. We have had intervention of rural electrification agencies, mainly using solar photovoltaic, but that's not enough. We cannot industrialize at that scale. So we also need to, secondly, look at the disparity in per capita energy consumption and energy intensity among these countries. And thirdly, the challenge of relying heavily on fossil fuels to meet energy demand. This challenge further affects climate change and delays the attainment of net zero and carbon neutrality in Africa. Again, recognizing the above challenges, we are then saying, let us continue to review our policies such that we will not continue to be referred. This is the map of the world at night, if you integrate it. That's why you see that Africa is the dark continent at night. We can't continue like that. We cannot live under this scenario because we need to leave no man and no place behind. Again, why is energy so critical for Africa? It's so critical because it's the engine of economic and social development. Again, the SDGs are universal to the call for action to end poverty and then protect the planet, ensure that all people enjoy peace and prosperity, among others. Again, SDG 7 is important to derive all the other 17 goals. It's at the center. You cannot provide good health in dark. You cannot be innovative in the dark. You cannot achieve any of those, even education. So it's at the epicenter, like engineering. You can't achieve any of those 17 goals without engineering. So it's important that we then need to address energy efficiency to those countries that are endowed with enough energy access. And then also we need to reduce energy intensity by going into demand-side management and also energy efficiency in terms of our systems. Well, let us deal with sustainable development in an integrated manner. When you are looking at sustainable development, it simply means we are going to leave this world a better place than we found it. And also in energy, which is probably one of the biggest polluters, we must also ensure that we integrate the 3 principles I hinted to. One is we should leave no one behind. We should have dignified life for all mankind. And then we should also look at equity and prosperity within the support systems. This is why we are calling for a just energy transition. And we should also increase capital for greater resilience and integration equity. If you remember way back from the Rio summit in Brazil, this call for us to look at the planet, people, and prosperity. Then there was the WSSD issues, and then now Paris 2015, and many other interventions, all these leading to the goals. And now people are thinking about these successor SMART goals. I think the World Federation president, we should now start engaging the United Nations on what next after 2030, the next goals, which should be smarter and more achievable. Again, this is the way to go. We need to ensure that the goals eliminate poverty through an inclusive green economy. Globally, like I've said, the rest of the world produced about 30,000 terawatt hours of electricity. And coal still leads the charge when it comes to electricity, representing somewhat 34%, 35-34%. But when you look at those without electricity, it can go up to as far as 70 or so, because there are still some countries that top the list of the use of coal. China, the statistics of 2022 is that it's about 53% they are still using coal. And of course, there are some countries like India, as well as the US and Australia, who are still endowed with the resource, but they still need to continue to look at it. Renewables, at that time, were at almost 14.4%. So let us try and look at how Africa can now then transition in a just manner. You can look at what we have, unlimited solar potential, you see, versus what all the world requires. Then you look at abundant hydro, 350 gigawatts, wind, and geothermal energy sources, especially in Kenya and some other Rift Valley countries with that resource. So we do have that endowment of all those energy, solar, marine, for those coastal countries, but the rest of the countries are landlocked. So which is why I was smiling when he was talking about the nuclear options, especially the nuclear microgrids. I'll tell you the WFEO recommended years back that the safest energy generation source was nuclear. And at that time, we lost to political science, we lost to politicians, we lost to emotions because of Fukushima and many other indicators. But now reality is come back. So again, the potential is very high, but potential is just potential. We have lots of minerals. For those that will receive the presentation, you see even the nuclear. We have all those iron, we have zinc, we have, as much as you would need in the value chain of energy production. All those minerals are abundant in Africa. So we really need to ensure that we optimize on this and address, first of all, access to electricity. You see, most of the people now without electricity, about 2 or so billion or more, are living in the developing world. And we need to change this narrative. And when you look at sub-Saharan Africa, about 600 million people without electricity, that's not right. So it's something that's the problem. I will not talk much about, but to support Professor, to say that the future of African engineering energy transition would largely rest on the small modular reactors or micro modular reactors and other nuclear interventions because of the low maximum demand in Africa. We must take this nuclear coal seriously. Of course, it is endowed with its own problems of waste management, which engineers should strive to solve. Again, there's a wake-up call for Africa. During COP27, that was in Egypt, around 89%, it was revealed that or the LNG infrastructure being built is not for Africa, it's for export. So as much as it's in Africa, you find still it's exported. So these are some of the challenges. Again, the IEA projected that even if Africa developed all known gas reserves, it will not pollute beyond 3.5%. You see? So what transition? So we live in one world. So I think here we don't want to address a problem where it doesn't apply. So we really need to look at the cost of transition to net zero. It's significant already for prosperous countries like the UK, China, and everybody else. But we are saying we are in one world, we will still transition. So let us work together. The polluters need to pay. There's now a new phenomenon where there are carbon credits, where they are buying forests in Africa and in many other countries, so that they can continue to pollute as if nothing is happening. By they, I mean those that are buying the carbon credits. That's not morally right. So we really need to stop the bigger picture, the critical mass, Pareto, 80-20. If we stop the 20, it will not much impact. So let us think about it as we talk about energy transition, that the contexts are completely different. Yeah, I'm not complaining. I'm looking for solutions. So we believe the future of energy is low carbon. And to achieve this, African countries should first industrialize and then gradually utilize portfolio carbon intensity, PCI systems, that encompasses the full value chain and carbon intensity of the products and services used. This I'm quoting President Mustafa's Shehu. We need to industrialize, because what do we transition from if we are not industrialized? So in attempting to address Africa's energy gap, unconventional solutions and innovation must be employed. Again, Africa must be open to all solutions and options, and I really smiled all the way through your paper, Professor, the nuclear paper. And again, African energy systems must also look at large-scale deployment of advanced coal technology with carbon capture and storage. Of course, clean coal development. I know this is contentious, but it's so abundant that when you then want to use some other renewables in court, you may need to interrogate the value chain of the production of the renewable components. You find them not so renewable if you want to be analytic. How much energy from fossil fuel is burnt to produce a solar panel? Just do your research. I'm not saying let's not do it, but let's think about it. Mini grids can be employed in provision of energy to rural areas and small towns, while conventional systems with some renewable solutions will also bring stability into the grid. Again, we need that all-inclusive global policy framework to facilitate the flow of finance, capacity building, and technologies between countries. The polluter must pay principle and implementation of the Paris Agreement by all countries will go a long way to improve the carbon footprint of the world. Again, we need to recommend a just energy transition for Africa. Energy plays fundamental roles across multiple sectors. The choices Africa make about energy systems will determine many other aspects of development. One, are they fit for purpose? Are they modern and low carbon? And we need a new model of energy provision that must address a number of important factors. The system must provide accessible, affordable, reliable, and sustainable energy to around 600 Africans that currently lack electricity. To achieve this, we must ensure that African ownership and agency in energy initiatives and plans is prioritized so that we can bring to the fore this context. To say there are some countries with less than 20% penetration of electricity, that's really bad. Integrating energy systems design into wider development objectives and planning is important, and also establishing clear policy priorities such as support for clean cooking and diversification of energy generation and ownership. We also need to provide scope for delivery of energy as a common good and to genuinely foster energy democratization. We want to ensure stakeholder participation, equity, and sufficiency in the terms of use. The takeaways are mainly that let us follow the aspirations of the Agenda 2063 of the Africa we want, and let us further identify financial funding incentives mechanism needed to best position Africa to meet the energy challenges of the future. We have noted that net zero transition model was initiated by developed countries with established and diverse energy systems, and that the top 4 emitting countries already described contribute to a significant amount, and they should assist the 54 countries who are only contributing less than 3.5. Africa has stayed very long without meeting its energy needs. There's now a growing awareness among African leaders that the solution to the problem can only be sought when the continent looks at all its peculiarity of its problem and take action from that perspective. In that respect, all options, energy sources need to be considered. Africa energy policies should follow a just pathway informed by international best practices and lessons learned elsewhere. We have learned a lot from Portugal. Coming here was so valuable that we will take most of the lessons away. Thank you very much, Professor Vieira, and also the ODEM, President Fernando, for great job, and the speakers were of high quality. It is very, very important that I now quote again the president of the WFEO, Mustafa Shehu. He says, the continent needs to have enough energy to industrialize first, before it can fully join the industrialized countries in the energy transition journey. Or within, as we transition, we need to build that access. Again, the president, His Excellency, Deputy President of South Africa, says we cannot transition in the dark. Certainly we can't. In conclusion, it can be concluded that some emerging key considerations for energy transition policy for Africa include security of supply, environmental sustainability, accessibility and affordability, innovation and research. R&D is important, and also modern competition. It's also important that our emissions being as low as that, we must ensure that we focus on issues regarding energy transition, should consider the women in the villages, the vast unemployed, intelligent and vibrant youths. You know, we have 70% of young people who are below the age of 30 by 2030. So these boys and girls on the street without food must also be considered as we talk of these energy policies. We should focus on economic and human development of the African continent, and again balance with the carbon reduction, net zero emission, or reduction to net zero emission issues with due care to energy access. In conclusion, we always say, if you want to go fast, go alone. And if you want to go far, let us go together with the rest of the world. And I thank you. Thank you very much.
Thank you, Martin, for remembering us of the importance of energy to the African development. Now we have and before the closing remarks, communication about reinforcement of the energy interconnections and the optimization of the energy markets in Europe. Engineer Marlene Vaiani, Secretary General, Conseil Français de l'Énergie France. Marlene Vaiani is the editorial director of the La Revue de l'Énergie and president of the Energy Committee of the World Federation of Engineering Organization. An engineer by training, she has spent her entire career in the energy sector. After teaching through research at the French Atomic Energy and Alternative Energy Commission. She joined EDF, Electricité de France, Studies and Research Department to work on the optimized management of water use in dams. She is involved in development of new dispatching systems within the framework of the Electricity Transmission Network Manager, RTE. An engineer from ANSTA, I don't know what is meaning, yeah. Marlene Vaiani holds an executive MBA from Paris School of Advanced Commercial Studies and has been an auditor for the national sessions of Institut des Hautes Études de Défense Nationale and also of the Cycle of Advanced Studies for Economic Development and also Institute of Advanced Studies for Science and Technology. Please, the floor is yours.
Thank you. Thank you for this very long presentation. I'm very happy to be with you. I would like to thank Ordem dos Engenheiros and WFEO for inviting me to share some thought about energy interconnection and European markets. First of all, I would like to start with a message of responsibility and of hope, because I'm an optimistic. I'm sure that you have all read the last report of the International Panel of Climate Change Experts. It's quite depressive, regarding the increase of temperature and the consequences of climate change, but among this huge work, there is something very positive. The thing positive is this yellow sentence. It says that we have already solution, feasible and low-cost solution to deal with climate change between mitigation and also adaptation. And just to show you, I will not enter in the detail, but to show you the solution and the cost assessment they made, you can see that all the impact of energy supply sources which are already available, so we see, of course, solar, wind, but also nuclear, this solution can be really help to decrease the global emission by half of the current total of emission at a cost lower than $100 ton equivalent, CO2 equivalent. It's a huge cost, but it's less than doing nothing. And this message is a very positive message. It shows also our responsibility as engineers to develop and to implement such solution. And before entering the European energy market, I would like to share with you, and maybe some of you already know it, a tool which is developed since, I think, 15 years by the World Energy Council. It's the World Energy Trilemma. It's an index. It's not a predictive of a prediction of what the future of energy will be in your country, but it assesses based on public data the kind of balance or equilibrium of your energy policy regarding 3 criteria. And it is based on the assumption that if you forget one or maybe 2 of these dimensions during a long time, crisis may emerge. And the 3 criteria, I think maybe all of the speakers have already discussed about that. The first one, probably one who was really forgotten in Europe since the last decade, is energy security. The second one is called energy affordability or sometimes energy equity. When you have not enough energy for your people, where energy is too expensive, it's difficult to take care about environmental sustainability. It's just an example of how this kind of tool, which is a tool of leadership conversation, can be used. If you are interested to know how your country is ranked with that, according to that index, I encourage you to show the publication of the 2024 index, which will be issued in the next months. And I will just, after that, apply it to Europe.
as you know, or not maybe, Europe is strongly dependent on energy import. It's not at all a region which is autonomous in energy, and far from that. We can see here, let's say, here, what is the energy own production of Europe today. It's mainly based on renewable, the 40%, and nuclear. Even if Europe sometimes does not like nuclear, nuclear is a key part of Europe's energy mix. The other part are oil and natural gas. But this energy production is not at all sufficient to cover our needs on energy consumption. And you can see here, this, I don't know if you can see, this here is European energy dependency rate between 2000 and 2021. We have developed a lot of energy renewable during that period. It has cost a lot of euros. And you can see the impact on the energy dependency rate. It's almost not visible. Here are all the European countries, and you can see that it's not very brilliant, even for the best. Here, Europe is often communicating about the renewable and the need to develop renewable. When you look at the current European energy mix, it's mainly dominated by fossil fuel. And it's not new. It's still the case since decades. And this is not very optimistic, but what is optimistic is the ambition of Europe as a region. In fact, Europe on the state that she would like to be the first climate-neutral continent by 2050, which is very, very ambitious. And we are starting from a very difficult position for that. But that means this kind of evolution in the energy emission. It's quite, we are. So the worst part is to come. And what does that mean? How can we realize that? It will be a very complex transformation of the entire society to do. Why? Because first of all, we have to decrease on a very important way our energy consumption. It's something people don't like. That means we do not have to take plane. We have to forget the car, or mainly the fossil fuel car. We have to take, I don't know, the bike, and a lot of things that everybody would have to change for that. The other part is we have to increase drastically our electricity low carbon offer. That means electricity produced with renewable and nuclear. And the other one is, of course, we have to exit as far as we can from fossil fuel. And fossil fuel are very used today in our European industry, in particular in Germany, but not only in Germany, in all the European industry. So if you remind the energy trilemma, this will not be easy, because there are an easy part of that work. But there is a strong and a difficult part, which is transforming our society and the way we use energy. And it's not only a matter of energy generation, it's a matter of transforming all the use of energy. So it may be difficult, but we have to, of course. Another element is electricity interconnection, or more generally interconnection. They exist before Europe was talking about energy market. When I started working 30 years ago, the European market does not exist, but we had interconnection, and very useful, in particular for security of supply. So this is not a new thing bring by the market. It's something which exists and pre-exists to the electricity and power market. I will speak at the beginning of the electricity interconnector. Why? Because electrification will clearly be one of the most priority of the European energy policy. And interconnection will have a key role, developing interconnection will have a key role on helping developing that electrification. I think, because I've read that on a lot of TSO statement, that European market is probably the biggest electricity market interconnected. That means that we are operating, all the TSOs are operating in real time more than 300,000 of kilometers of electric line, transmission line. And we are operating more than 400 interconnections. And the projects are in the different colors. It's not very readable, but it's regarding European interconnection, it is the most important size of project. 141 projects of interconnection to increase the security of supply in the European market. And just a point to speak about energy and progress in energy technology. When I started working on energy transmission, that kind of submarine cable between UK and Norway, between Romania and Georgia, between Egypt and Greece, wasn't possible. It was too costly, not economically viable, and a real technical challenge. Today, there seems to be a real project with feasibility. So that means progress, a technical progress, and engineers are a key role to play on that part, can help to that, to the development of the energy transition. Now, sorry for this awful diagram. The gas, the gas interconnected network. This is a quite different situation compared to the electricity. There are only 25 projects of interconnection in the whole European gas market, and they are mainly in the east part. You can see in the red, if you can see something in red, they are mainly on the eastern part of Europe. But this is normal because gas, natural gas, has not a part so important as electricity to play in the energy transition. But it may have a part on hydrogen. I'm sure you are aware that a lot of transmission operator of gas would like to convert the current gas infrastructure to hydrogen and also develop new one. And this is a project of all the different players in hydrogen who want to develop and applying for European support to develop a full network of hydrogen interconnection. This is on the paper because that needs to be developed, of course, to have real increasing demand on clean hydrogen and production on clean hydrogen. There's also a few comments on the difference. You can see that France, there is not a lot of transmission project, and there are a lot in Germany. Why? Because by 2030, France's strategy on hydrogen rely more on inland production. So we would like to produce our clean hydrogen using mainly nuclear electricity. In Germany, their need are so important, and they have not enough electricity, clean electricity, so they need to rely on import. And they rely on massive import from all over the world. That's why they absolutely need to develop such network on hydrogen. And this is really a key difference and sometimes a key source of tension between countries, because we have not the same national interest. Other new networks, CO2 networks. These are the project, not the reality, but the project. And they are planned to support the CCS, carbon capture and storage, and use, we hope, of CO2 emission of Europe, but also of national strategies. So this network will be built to capture CO2 from the emission side, mainly industrial side, and to bring them to storage capacity or also reuse it for industrial process project. This is the beginning, but this is also the new other kind of infrastructure that will be developed in Europe. Challenges with energy interconnection and more generally with energy transmission and distribution operation. The first one, I think everybody or quite has spoke about it, it's energy flexibility, and to be more precise, electricity flexibility with the huge increase of renewable variable energy, I mean solar and wind, but particularly solar, with the duck curve of the consumption it generates. This will be huge. And if we don't want to develop, like the Germany did, gas power plant to manage the flexibility, but also to create some assets who may not have a future, there is a real challenge, first to develop interconnection, so to optimize and mutualize this kind of flexibility, but also to develop demand-side response solution. And clearly in France, but I think in different European countries, we absolutely need to develop that kind of response if we want to manage in a costly manner and also in an environmental manner the energy flexibility and not increase the security of supply or decrease security of supply. Other challenge is more about what has created a lot of discussion and tension in Europe last year, which is market design. And in fact, when we spoke about market design, we spoke more electricity market design than other kind of market design. I think everybody in Europe, in the energy sector, has a position, maybe had a position on that side, and this position can be very, very different. So I will not say the good position is, because I think it's not possible. It depends on what is your country, what is the resources, and what are your interests. What I just say is that probably there is a kind of consensus today in Europe that the spot market, so the very short-term market, are quite efficient in the way they help to allocate generation. But there is still a lack of good signal, price signal for long-term investment in generation, or in particular in clean energy generation. The other maybe consensus is that we need to find the right signal or to create the right signal to develop flexibility from customers. Because it exists, I think, I'm sure that it exists in every country, but it's not enough to face the challenge we have to face. And I think we haven't seen it coming so quickly, linked to the development, the high development of solar energy in all Europe. And the other challenge, which may be more complex because it captures more uncertainties, is this one. It's a kind of cross-planification between all the energy sources to avoid some stupid or totally inefficient at the European level investment or operation. So maybe it's a dream, but it's what the European transmission operator calls. It's a kind of planification between heat, mobility, electricity, hydrogen, and green fuel, just to be sure that at every level, so we can dream, but it's important to set target. At every level, decision remains, of course, to the different national states about energy, but they know and they discuss and they try to cross-planify between sectors the development. And last subject, but not the least, which is probably one of the most surprising, not surprising, but the rupture of the European Union discussion is industrialization, or the coming back. I don't know if there is someday one, but maybe the renaissance of the industrial policy in energy. 30 years ago, nobody was speaking at the European level about that because it was not the priority. The priority was to open market because energy was supposed to be abundant and cheap. And this was the case at that period. After COVID and crisis on European markets, and the fact that the European industry can really be destroyed, I don't know, but weakened by the high energy prices, European Union really make a switch. Probably, of course, because they would like to respond to the US Inflation Reduction Act, which is also maybe a red flag for them. And they developed two kind of action. The first one was a Green Deal industrial plan. And the second one, we have already spoke about one of these, are the industrial alliances. It's not perfect, but it's compatible with the commercial policy of the European Union. It's compatible with the European tools. They start with the European Battery Alliance in 2007, which may be criticized, but today we are gigafactories of energy battery. We have also, not right after, but after a European Raw Material Alliance. We have also an alliance on clean hydrogen, industrial solar PV, and the RLCF is on renewable low-carbon fuels. And the last one, but not the least, and which was developed in your previous intervention, is on small modular nuclear reactor. This is very a turning point of the European Union, because nuclear was quite taboo at the European level, and now it is not. So this is, from France, a good point, and maybe not for France, as we have a lot of other European countries involved in that alliances. And last but not least, what is missing, the most important, what at the World Energy Council we call humanizing energy. I think that probably in all European countries, and maybe in all the world, to face and to achieve the energy transition, we absolutely need skilled people, and in particular scientific, engineer and scientific. And we are in Europe already facing a lack of attractivity for science, but also for energy industry sector. That's why I think maybe as WFEO, UNESCO, National Organization of Engineers, we can help to achieve this kind of attractivity on the energy sector, but maybe on all the sectors, because we really need to achieve that. If not, we will not be able clearly to achieve the energy transition. In France, some projects cannot be delivered because there are not enough people wanting to work on that side. And just to finish on the sentence UNESCO said the 11th of February is about attracting young people, but also young women in the energy sector and in science in general. And they say UNESCO, the world needs science, and I think energy needs science. Science to rationalize different arguments, science to maybe be a counterpower to political advocacy or different thing. Rationality. I think we need more than ever that kind of science. And also we need more than ever women in science and women in energy. And thank you for giving me the floor for that.
Thank you, Marlene, for stressing the importance of the interconnection, the markets, the change of European policies, and more important, the people and interest for young people to these matters. And for closing remarks, and before, I call your attention for the buses are waiting for us at 7:30 at the door in the entrance of this building, the old building. And the closing remarks, I will call for Mr. Engineer Seng Xuan Tang, WFEO President-elect from Singapore. He is graduated from National University of Singapore in 1983. And Engineer Seng Xuan Tang is the former president of the Institution of Engineers, Singapore, past president of the Federation of Engineering Institutions of Asia, and Pacific and vice president of World Federation of Engineer Organization. Presently, he is the chairman of Asia-Pacific Economic Cooperation Engineers Coordination Committee, treasurer of and executive board member of WFEO, and governing board member of International Engineers Alliance. Please.
So I'm sure you all agree that this afternoon is a very fruitful and very productive afternoon, right? So, yeah. So, ladies and gentlemen, I won't take up too much time just to do the closing. So I just want to say that welcome to the end of this World Engineering Day. And it has been a long, fruitful days. And thank you for being such a wonderful audience. I see quite a number of you still stay behind to listen to our fellow engineers to share their experience. And through this afternoon's conference, Energy Transition and Sustainability, we have been once again reminded the urgency of the world to transition to sustainable energy source and practice, so as to tackle the global climate crisis and foster a sustainable future. The world definitely needs a transition to renewable energy, and transitions must be switched. According to the IPCC, approximately 2/3 of the global greenhouse gas emissions can be attributed to CO2 from fossil fuel combustions and industrial processes. Sustainable energy is vital in decarbonizing the energy supply and putting the emission reduction goal laid out by the Paris Agreement within reach. The good news is significant progress has been made. You will hear from our speakers this afternoon. There's a lot of development. And it's not only a technology development. I think we do need political developments in terms of adapting the renewable energy. So over the year, renewable energy technology has become better, cheaper, and easier to access. However, renewable energy sources are only responsible for just 20% of our global energy consumptions. So we still have a lot more to go, just like Martin was mentioning, a long way to go. And this is due to the challenge in energy storage, cost, economic infrastructure, and the political will as well. So on nuclear aspect, public acceptance is very important to understand the safety and security aspect of the nuclear power. These are colossal challenge, and no engineers will be able to address in isolation. So WFEO create a platform for all our engineers to come together and we share our knowledge. Although today's conference may not have given us every answer of it, but we need to tackle problems at hand. It has brought us together to exchange valuable knowledge and ideas with each other to accelerate our efforts towards success. From developing groundbreaking technology innovations to contribute to vital policy considerations, engineers has the power to drive sustainable development within the energy sector and shape the global energy landscape. Through united efforts, we can harness our collective expertise to carve a pathway towards more sustainable future. As we close these sessions, I hope all of us would not just take away the knowledge gained, but translate it into tangible actions and initiatives within our own respective field and organization. And we bring back to our own country to see what we can do to take more actions from the knowledge we gain. Let us continue to champion sustainability efforts, advocate for policy change, and drive innovations in our community and industry. Lastly, I would like to express my heartfelt gratitude to all our speakers for sharing our invaluable insight with us. Order of Engineers, Portugal, for hosting such a wonderful event and organizing this event to celebrate engineering and contribution to the world engineer for a better, sustainable world. Let us remain steadfast in our commitment to effect change through engineering and build a world where energy is not only abundant but also environmental friendly and responsible. Once again, thank you very much for your participation. I look forward to seeing you at the gala dinner, as well as tomorrow's, those who have stayed back for the meeting, and those who are not involved in the meeting, have a safe travel back to your own country. Thank you very much.
How did we get here? We progressed. We empowered. We innovated. How did we do it? With engineering. And we're still going further together. For us, for the planet, for the future.